it's so inconvenient because this is no longer Scratch, you have no one. All of a sudden, your machine no longer boots. And that's it. You have lost everything if you don't have it. It's not like bad, bad sector or something like that we had before. It's on and off. So.
Do you need a mic?
Thank you for this thing. Here's one.
Oh, I see one there.
Oh, you mean a speaker coming out?
Mic. No,
Oh, there, yes. No.
that's a bummer. That's the bug. You're at this, just.
Yeah.
Is that because the SSDs are that they work that way?
Yeah, I see.
You might get some warning.
No, I went back on vacation. I just tried to turn on my machine.
No, I understand you didn't get me, but I wonder if there's a way you can like check the health of it. I mean, it should know because the way the SSD works is like new data always goes in new places, right? Something like that, because they wear out, so it should know when it's getting close.
Maybe, but no one can warn me about anything. Or maybe it did, but
Less money in the operating system than the operating system. So maybe you have to like turn on some.
I'm not sure.
thing.
I'm not sure it's actually right. I'm not sure that there is less money in that. I'm not sure that the number of contributor is higher for this than for that way. Because I remember in the past, from one version to the other, the number of lines that change is much higher on Linux than on anything else. Yeah, it's a community so large.
The community is very large.
And it is improving like crazy. So I don't know a number right now, but and that's true that Apple is so well see that
There's huge amounts of it.
yeah, sure. But in the next it's really very
What's going on here?
reading.
Can you run top? Yeah.
Maybe that's the thing. Yeah,
It's
it is only
surprising that nothing is advancing though. How much CPU do you use? Only one core?
yeah.
Everybody's blocked on.
It is combining. Yeah, it is.
Yeah. So this if you go here,
It's combining.
if you go to this,
Yeah, it is slowly moving.
on top of it. So these are your, like, it's trying to use 8 cores, and it's showing you core number 1. These are all, it's 1 through 7 are all blocked, waiting for this thing to finish before they're. Actually, there's something wrong. This doesn't make sense. It doesn't make sense that these 7 things blocked, not all in the same file. Maybe it makes sense. Yeah, but that makes. Manuel's Rhombus installation is ridiculously slow.
The Rhombus installation or like installing it?
Filezios.
It's still going.
Yeah, only 1 core at a time, but also it's like, it's really slow. It's surprisingly slow.
It is compiling reco/main.rtp for minutes.
Here, look.
But here it
This
must
is maybe not.
that may say.
Yes, oh yeah, I forgot about that.
It's like because well, no, it is only CPU extensively.
What version of Racket are you using? Did you get the snapshot version or did you use the one you already had?
Which version of that?
That's the one that comes with Debian.
That one up.
That's probably.
Yeah, that's.
Yeah. Just download for now. Just download a snapshot. Won't mess up your existing.
Which is where because it's so.
Well, if you go to that, then it'll
Yeah.
give you a link to install.
The page you were on.
Yeah, this go back to you. Yeah. Okay.
Yeah, you can install it in a separate
Yeah,
directory.
just
and
like
it
the
will-
local.
Yeah, except that today it's Debian 13.
Different thing.
So when you write so many versions from Debian, it doesn't matter.
Well, we could have two versions, because it. Or what you're gonna do it, doesn't matter. If you're doing something related to terminal IO, so. I'd have two versions of it.
Yeah, I did, but actually we're going.
Wait, what downloading?
You already have this installed? Do you already have Rhombus installed?
I see it on this. It's on the screen.
Hi. All right, assuming you don't already have Rhombus installed, if you follow these links, then it will help you get it installed. If this is intended to be a hands-on workshop where you write some practical programs.
Section P.
No, four, option 4.
Yeah, I don't want to do this. I am in section P.
Oh, right, you can go there one.
But which is.
That's take quite a while to install.
Yeah, so are you installing on top of Racket or with the snapshot?
On top of it.
Okay.
I
And
don't,
which version of Racket are you using?
I think it's 8.18, I don't know what the number of versions.
Yeah.
No, I think there's a web page that says something else. The web page says.
Yeah, you're good. Right, let's try.
Yeah, if it's,
We
we
should have
should
put-
used to take too long, just doing a separate snapshot, might be the way to go. Follow these links, and it'll give you to a download of a snapshot.
Go back to your turn. You just Dr. Rocket.
Yeah, because I've already done this.
Okay, I know people are getting things installed yet, still, that's fine. But there's some work for you to keep doing anyway after you get it installed, so keep installing and then go on to the crash course. Exercises on the webpage, this is the link again. And that's just to get you basically familiar with Rhombus and see how things are going. The intent is that you guess at how it works. And ask me or Robbie for help.
So now I'm going trying to do this. But actually, before we can get this, I obviously do environment, I should make sure. Yeah. No space,
No spaces, like that.
no slash. It's then space. Yeah, just here.
Range.
So, yeah, so. I'm gonna go.
I can't, I use Mixos, so I can't. Sorry, I'm changed.
Okay.
It's installed.
As long as it's making progress, yeah.
But is it?
It will get stuck for a while because it's taking all of Rhombus and then recompiling it as a monolithic thing.
You're.
But the snapshot should just work.
I would install a snapshot, but I have Mixos, so not an option for me, unfortunately.
Yeah, I get used to teaching undergraduates. I forgot grad students and professors are gonna have NixOS.
So this is what version of bracket? So,
I think it's 8.18.
yeah, so you might need, is 8.18 okay, or does it need?
8.18 is fine.
Okay.
A little bit.
The snapshot is actually, you can't write binaries into arbitrary.
NixOS is not
It's
gonna.
an immutable like operating system. It's all declarative, like I know, unfortunately, no.
So you can't do like.
Hi, welcome. Go ahead and install Rhombus.
See?
Something you're expected to be doing. Rhombus, you're in that place.
I can compile them like that, yeah, it's just I can't like put them into this money install.
So the intent of the tutorial is hands-on. If you follow this link, you'll get a place to install Rhombus. Even if you have Racken installed, if you haven't installed Rhombus, I recommend just getting the snapshot and having a separate installation, assuming your OS is happy enough with that. And then move on to the crash course exercises to warm up.
And I kind of actually like installing.
You can ask me or Ravi if you run into issues.
Something out. Yeah. You have any trouble? You got the one with the. Yeah. It's fine. Yeah.
Maybe but that way. Wait a second.
Really good to documentation. You can just do it. Let's see. Take it advice. So that'll take another day.
Okay. I think so. Oh, yeah. Let's see. Oh, yeah.
See that it's.
Yeah, okay.
We are installing Rhombus, intended to be a hands-on tutorial.
Excellent.
And so if you follow it, we'll get there, and then there's some exercises for you to do. The intent of the crash course is that you guess. Just get a sense of Rhombus and try to see how it works by poking at an example.
No, wait, you load the file, just run. And it will load it, let me check on this. Yeah.
Which file?
Oh,
yeah. Actually, if you edit it here and hit run, it doesn't have to be saved necessarily.
Can I say what we, you know, we go?
Oh, you changed it on this in a different editor.
Yeah, on Max.
Oh, yeah, reverse.
Just for Rhombus on the command line that.
Seriously.
Oh, yeah, okay.
Yeah.
We can just run Racken on the command line. using your installer for the project.
Okay, yeah.
There's also a wrong design something original.
Long ends.
Yeah, so I mean, it might be easier to stick with that.
Yeah, but the exact director will help you with the various things. Such as like, it's your friend that has. It's a doctor, it's a doctor, it's a help you. Okay, he's talking about you, about how to help you. So. Don't do it for me, explain it. I just want to make more. So it's telling you wrong indentation right here. Maybe you can guess. No, I cannot because it's exactly the same thing. No, it's not. Look again. Oh, I have one character? Yeah. Okay, because minus is one extra one, okay. And also, also tabs, means just go to a good place.
Maybe that's the install stuff.
Yeah.
So, but yeah, you want to, how to run it.
If I have Windows
Bracket
66
interpret.
Linux, like that, I'm assuming you didn't Linux side or just Windows side.
Where people go to where you brackets. Yeah. Bracket. Kids.
I think it's called.
Okay. Yeah, okay, okay, yeah, I can have both. Yeah.
Okay, command should be easy, or something, whatever menu. key
Oh, aren't you
is,
glad you got to take PO?
Maybe on this Mac works, and or just suck it into Dr. Revert file.
Control E.
Go back to Dr. Rabbit person. File.
Because this is not this one, that's the one. Maybe.
Revert somewhere here. This one. Shift control.
So I guess we.
Okay.
That means get it back.
Okay, 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 thanks.
Yeah. That's gonna be. Just. Yes, and I'm looking at life and see the next meeting.
Yeah, good. But you also know, you already have a conditional file. It's in this file. That you put out there.
That's true.
Yes, man, I tried it. There is an if though. I like that. I like that.
Well, there's a pattern action presumably.
You have to get it.
And then there are true and falses.
Right, exactly.
But then don't
Guessing
you-
involved no matter what.
Yeah, exactly. But yeah, there was.
Also, the thing also it's not guessing is the tab is the.
For invitation.
I feel like it's smart about that.
So I was glad.
Oh, you found that one already?
Yeah.
So there's more than one legal place, and so just go to the potential legal places.
Yeah, I mean, that's super, I use estimate.
Okay.
That's exactly.
Same
what
thing,
it's
okay.
supposed to.
Okay. Yeah.
I assume when you get to the end and you hit tab, you go back to the.
That's right. Or I forget which way.
Is that giving you a sense of where we are? How many people managed to install around this? Looking at interp one, the first exercise example, anyone made it to two?
The one goes
Yeah.
one way, one goes the other.
Somebody till two, anyone made it all the way to three? Alright, fair enough.
I just don't like it myself, but good back.
That's fine.
Yeah.
Did you get the internet?
Well,
Okay, so you try. Instead of.
That is just the.
Oh, it's when you saw it from the US. Okay. Yeah, it'll go a little farther. Yeah. It's ready to go. You can start out just installing. Out this, yeah.
How do you open the RHM file?
bracket, you can just say, okay, that might just.
Ah,
Yeah, if you double click and when it doesn't go.
Okay.
Oh.
Yes.
Very good install.
You got it installed. We can see what you're.
Oh, no, but you want to.
I want to open Dr. Rabbit, okay. I just typed racket, that's what I got.
Yeah, are you? Are you?
Next question.
So like, I didn't even realize that was like. But.
Okay, yeah, that's okay, that's confusing.
Good, thanks.
So I don't know if this is a and so like I'm from but I it's just yeah, you should.
You can go to the crash questions.
I was just trying to do an exercise and I didn't know what the statement for.
Ah, okay.
Oh, yeah, I guess I can.
Use them not true, so. And the answer to that is it starts with an hash.
Okay.
But there is if, and you could try poking around and guess what this word is. You probably wouldn't get it wrong so many times. Why guess? You could try, so there is it.
Yes, it is on the screen.
You can change the pick out.
It's just a difference in a few photos, very nice.
Yeah. It's a solution. Yeah, I know, I could actually.
I'll just let you know this. Oh. Yes.
Yeah. What guesses you know?
Oh, I didn't, so I've done some like practice.
Yes.
Yeah, originally, seems like you could diploma.
Yes, of course.
But I mean, I.
Then you did, so.
Yeah, well, I looked up here, I noticed.
Put your mouse on that cell on here. Yeah, so. That makes it happy.
Yeah, and so this was originally.
Is it working?
I think you know, more like that.
And then what's the,
And I
what's
was-
the soft,
Yeah, if you go.
It says, I'm running this place,
Okay.
something. And you do that.
Yeah, it's trying to, when it's trying to treat the.
Yeah, so that's a.
Oh, okay, thanks for this.
You'll see.
Yeah.
Okay, I'm gonna let you work for a couple of more minutes and then I will go through my solutions at the front.
And if you uncomment the best spots.
Oh, yeah. Yeah, I know it's start with, I make the
Oh, yeah,
calculation
yeah,
and
yeah.
then do this, so then
See
it
if
goes.
fails.
Yeah, see if fails like it is. Oh, that's awesome.
That's a good, that's really good.
Okay, good.
Yeah.
I'm looking for cleaver screens and. This is dark mode. Dr. Racket thinks it's dark mode, but the OS thinks it's light mode, and here, the OS is.
All right, so part of the idea of this crash course was to also give us time to all get in at least sync of having Racket installed, our Rhombus, everything set up. But the intent of this first one is that you see, basically the kind of Java-ish style classes you're used to with a superclass expert. And so, you look at my solution here. Then given enough time, you would certainly add a minus in an if class here. And you would clearly know how to change the match to add minus and if cases and have recursive calls and metacircular interpreter, just use minus and rhombus to implement minus and so on. Right, and you might even add some test cases like this. So check is a test case form where you can use is, but would be normal. You can also check for exceptions and so on. Right, so that is non-meta programming, except we're using interpreters as an example, right? But just everyday sort of rhombus programming. Any questions on this much that you could try? You got stuck on something, it'd be good to ask. Okay, and then interpret 2, if you got that far. What we're supposed to do, add tuple. So what we're adding here is now we have functions with multiple arguments instead of just one argument. Right? And in retrospect, maybe a little pointer to draw your attention to that at first would have been a good idea. But if you look at the implementation now, where we have call, then you see we have call on a list of arguments. So square brackets mean list, dot, dot, dot means repetition. So we're pattern matching on a list of arguments. And then we're interpreting all of those arguments, right, by just having the interp argm call with dot, dot, dots after it. Okay? And I'm interpreting the function expression, which is supposed to give me a function. So I'm using functions to implement functions. Right? My function also accepts any number of arguments, and then it maps an extension of the environment, each argument name to the argument value that the function receives eventually. Right? So if you get these different counts, if the number of arguments you expected and the number you receive are different, you're going to get some sort of error. But otherwise, it'll match them up and go in parallel. Okay, so what we were hoping you would get from this exercise is a little practice with dot, dot, dot. Make sense, everyone? Again, we're not really doing meta programming yet, but the dot, 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 we're going to use a lot of dots. And so it's good to get some more practice with it. And so to implement tuple, where you have a list of argument expressions where you interpret all of them, and then you can just make that a list. And we don't do any things with listed, we just make tuples. Okay. And people seem to agree that this is a sensible thing to have in a language. That's good. All right. And what was interp 3? So I doubt many people got there. But in interp 3, instead of having classes, we're just using these things in quotes, single quotes directly. So this is more directly how you might write it in Lisp, where you just use the S expressions directly and interpret them over them instead of parsing separately or something like that. These single quote things, they're not strings. So inside of the single quotes, it's still the same sort of syntax that's outside the single quotes. Okay, and we're going to talk about that next. That's called shrubbery notation, is what's allowed inside the quotes. Just like when you quote something in Lisp, it still has to be an S expression. But the dot, dot, dot still work the same way as before, and $sign here is an escape. So this is saying to interpret an if, you match any number of terms to be the test expression, and then anything in the then and else after the vertical bars for the 2 branches. And then we interpret the test. If that's true, we interpret the then, otherwise we interpret the else. Does this make sense? Okay, so the same notion of dot, dot, dots we were just using in regular sort of classes and function calls, but just inside these quotes. You see here, we're pattern matching on something, and here we're generating a new syntax object by using the repetition that we found in the pattern. All right, so you can play with this, and if you did it, if you had enough time, you would poke around and eventually get something to run, I expect.
Question on the one you just showed before.
Okay.
Right, no, it's this file, but
This
just
one.
above it.
Okay.
Yeah, the if then else.
Okay.
So the dot dot dots. Is the dot 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 tied to the $sign?
That's a good question. We'll talk about this more, but the dot 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 is tied to whatever's before it.
Got it.
So it's the whole $sign then that is being replicated.
Got it.
So this dot is repeating the thing before it. It's the escape. Well, we'll use, let's see, where's an example where we use dot dot dots? Another place, maybe not in this file. Well, here.
In the other file, I think it was some nested ones.
Yeah, here's
Okay,
a busy estimate. We'll talk about this example more too. But here we've got dot 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 comma dot dot dot. So this dot 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 is, because it's after comma, repeating everything before the comma. So that's any number of arguments, each of which has any number of terms. Yes.
Yeah, so what the if expression is only. Yeah, this expression is also has dot dot dot.
Yeah, this is because the test expression could be, it could be like 1 less than 2. which is multiple terms, right? So we'll talk more about this too, but that's good. That's exactly one of the things I wanted you to see here. Yeah. Okay, so at this point, you're supposed to say, it looks reasonable, but I have questions, right? Exactly how does the syntax work? So let's dive into this a little more and continue on what we're talking about. Shrubbery notation, as I alluded, is inspired by S expressions in Lisp. So how many people are familiar with S expressions? Good, that's fine. I just assumed you would be, right? So S expressions, everything is in parentheses, and a nice thing about this is that you know everything's in parentheses as a first layer, so you have to get past that hurdle before it'll even consider whether you have well-formed functions and function calls and things like that, right? So Sriram Krishnamurthy called this a bicameral syntax, where you have to pass both layers of syntax in order for your program to work. Okay. And then I just would emphasize here today, one of these houses happens first, right? First, you have to get past the S expressions before you consider the other half. And the nice thing about that is the other half, the lambda call doesn't have to worry about the details of white space and everything. You define the syntax of lambda in terms of S expression. You say it's a parenthesized thing, you know, with the identifier lambda and then parenthesized things and so on, right? And there's no question about whether there's commas or whatever, because that's taken care of at the S expression layer. So rubbers is very similar. The layer that takes the role of S expression is called shrubbery, and it's intentionally more complex than the S expressions. But it still is similar in that there's a few things that happen at that layer that define the overall shape of things inside and outside the quotes, single quotes that we were talking about. And then we can define the syntax of our specific forms like function calls in terms of shrubbery notation, just analogous to doing it at the act expression layer. So it gives it a kind of consistency because not only do we need to worry about the core forms of the language, this is all about making new forms in your language. And so you know the basic rules for that, and your new forms only have to talk about the shrubbery layer of things. So S expressions, like this is an oversimplified, but the way we think about S expressions, right? It's either an atom, which is something like a number or a string or a symbol, or it's a parenthesized set of things. So that's the great virtue is it's super simple. Shrubbery notation is going to depart from the conventions and the style in two ways. One of them is that not only is it simple, you put parentheses everywhere, but the way you use S expression notation is you expect there really to be parentheses around everything you want to group. Right? You could in principle say open paren 1 plus 2 close paren, but you don't that much. But if you add times and so on, you're expected to group the times. Whereas in shrubbery notation, it's aiming for a syntax where you might have less explicit grouping and have another layer of parsing later. That's one trade-off, or one difference. And the other difference is sometimes in where there is the structure, where there is the tree structure, we're relying on separate lines and indentation to do things. So that's why functions have a colon and then the lines indented, and then this function call is outside. So going forward, to dive into this a little more, you need to realize I'm using two words in a technical way. When I say term, I mean an individual thing like F or X in parentheses. It's like one thing that can be a member of some other, right? When I use group, it's roughly one of these lines. So the X plus 1 is a group. And print line, open print X, close X, that's all one group. Right? This print line has two terms. The print and the parenthesized term. The parenthesized term here, inside of it has another group, which has just one term, which is X. And yeah. Here's another example. This is the same example. I've just put new lines around the parentheses to illustrate that this group with the print line and the parenthesized thing, it really goes, spans 3 lines, right? Because the parentheses make it go there. So roughly you can think of a group as being on a line, except really it has all of its terms, and one of those terms might be multi-line. All make sense? You know, this colon here starts a block. That whole block is the 1, 2, 3, 4th term of the group that starts with fun. So fun is a term, F is a term, parenthesized X is a term, and block starting with that colon is a term. And of course, the block term has multiple groups inside of it and so on. So we've got terms and groups that are back and forth, kind of in a mass expression-like way. And here's the abstract grammar of this. Sort of abstract grammar mixed with concrete tense. And it's saying that a group is any number of these items, and then maybe a block and maybe an alts. Right, so I'm going to terms are either these items or blocks or alts. These are the kind of terms we were looking at, and block. And then alts is the tricky one, at least when we get started here, because it's not just one vertical bar, it's any number of vertical bars. So the syntax of if is if test and then alts. And it's expecting, it turns out, two alternatives in the alts, but it's all one term for something that the alts is contained. Overall, the idea makes sense. Now, why do we make it this complicated and not more complicated? Well, these are uncontroversial, right? Having parentheses and square brackets and curly braces, even some S expression layers, languages like Clojure does that. The single quotes here are because we are dealing with metaprogramming and want to quote code in the same way. So we add that one. And then this colon group is so that it doesn't become a sea of parentheses or square brackets, so that we can use white space to do a lot more grouping. And then as we sort of played with this, we decided that conditionals or alternatives were very common and worth distinguishing. So we added alternatives as the core program. So that's why those particular pieces are there. And the grouping layer is because we don't want to put, times and plus and all of those things explicitly grouped. So most of the extra parsing is going to happen in these individual group sections. That's the general idea. So now it's time for you to play with it again. So this will be a much easier exercise than the warm-up exercises, but let me do a little more here, and then you'll be ready to do the exercises at the end of the shrubbery section. So over here. So you may notice I'm in Dr. Racket, but it says not hashlang racket at the top, it says hashlang shrubbery. So this is a different language than Rhombus. It also uses shrubbery notation, and its job is really just to tell you how that body parses. So when I run this, it shows me an S expression encoding of the shrubbery abstract structure. The multi here is because I have two different groups in my program overall. So you could read that as document. And then I have two groups, the start group and the end group. The start group, second term is a block, which has multiple groups inside of it and so on. If we modify this a little bit and I say hello plus 5, then you can see the 5 and the plus are terms that they should be in the same group as hello. Right? And if I run this, then you'll see it is, right? There's a group that has hello and plus and 5. Oh, the plus. Shrubbery distinguishes between operators versus identifiers. And the S expression encoding, we make it explicit when it was an operator. So that's all we're seeing there. So your exercise now is to do hashlang shrubbery for a moment. If you go back to the notes, go to the shrubbery section all the way at the end as an exercise, and it will show you some of these that you reverse engineer by writing something in the shrubbery form, shrubbery language, to get the same printout. Okay, so that will just give you a little practice of how shrubbery prints. Everyone clear where we are? Shrubbery section notes, exercise if you will. Give that one a try for a few more minutes.
Matthew, I have a question for you.
Yes. Yeah, okay.
The class school, you define it like that.
Yeah.
An arg which is up. I have tried to define couple like that.
Ah, yes.
The way it doesn't work.
Okay.
I understand I could mimic that, but
Yeah.
this should be the natural way of defining it. Because I'm using it like that.
Yeah, I think you're right. I have to think more about how to make it work. The issue here is you've got something that's almost a field, but it's a repetition. And we just don't have things in place where we can have repetitions as elements of it. Yes.
But since I'm using it that way,
Yeah.
it sounds natural to me.
I agree. It does.
Okay.
Yeah.
It was just a remark for you.
Yeah.
This is why you should learn like our main form. No?
Yeah, that's right. fix the design.
Yeah. These things inside the rooms falling and hitting the glass have to be identifier.
Yeah,
Yeah, they have to be fields.
yeah, I
Do
understand,
we allow for this?
I understand.
And then what,
I think everything could be made to work, just as.
It's always nice, so when you pick the rest of the way, it's seen that we already use it in that point.
so you're saying this is a shorthand for X code home listed expert.
Yeah.
Great. Yeah.
It's not done late.
Yeah, you gotta find the tutorial. Yeah. So just go to the bottom. And then exercises. So hopefully, we can read the best things. Oh, okay, so Dr. Beckwith, will insert new lines based on the limit. Oh, okay, sure, you have to rerun. Yeah, you have to rerun, but. Alright, you know, this is. Perfect. It's pretty printing, but it tells a pretty very how wide this stuff, but here. Which is so actually. Yeah. Oh, no. Yeah. How much are you seeing? Right? No, that's it's just want to be all this stuff.
All right, I'm just to see where we're going. How many have tried the first one and finished it? 1, 2, okay, great. And 3, 4. I think maybe should I work through one of the front and then.
21. So 20 minutes or we have
15 minutes. Get people on the agenda.
Well, the first one, no, it's a first item of the site.
Yeah, yeah. The first.
No, maybe so.
So it's easier time.
Yeah, but I see why we have $1.
Yeah.
Challenging, but.
Oh,
doable.
So this op just means it.
I guess it should be $1. Yeah. Yes, I have to read.
And also one.
I just.
Back to back. Easier because back to back. I don't know.
But it's
Yes, especially.
kind of okay. With what he does.
Yeah, it is. It's gonna.
Yeah, if I just load my file. Yes.
Working for God.
Okay, I'm gonna do the middle one. Just to see, so let's see, I see multi-group, and then I see quotes is the first interesting thing to my eye, right? They're in the first group. So quotes, you might have guessed, is the single quotes. And then inside of that, there's gonna be two groups. So I'm gonna expect two lines here. And then the first group inside the quotes, I've got the word math. And then I've got op, and then there's these vertical bars, which I didn't really think about how that was gonna print in S expressions. But it has to not be like a special dot, right? So it's just a dot at the rhombus level. And then max. And then you see parens. So like quotes, if you do enough experimenting, then you would get the idea that there should be parentheses there. And then I have two groups inside the parens. And I think this is the least obvious part.
Yeah.
Is that you would need to put a comma between them. You can put them on two lines if you want. But inside the parentheses, even if you put groups on different lines, it insists on there being a comma between these. Because if you left out a comma, you probably didn't mean to. So that's the rationale for that. So I'm going to be ready with a comma, and then I've got hello plus 5. And the only problem there is that it just didn't look sensible. And then world there. So I could put them on two lines or one line like this. I could leave out the spaces here. And that's all fine because shrubbery is gonna take care of that later, right? And then, am I done? Oh, there was, no, I'm not done. What do we do? Oh, I'm looking at
You
the
want the
old
dollar
one.
sign X.
I got distracted, sorry. I hope you're not confused. I jumped down here. I'm supposed to be looking here. So that's why I recreated what we had before. All right, so inside here, I had $X and just dot, dot, dot. And then at the end, there's a group op dot, dot, dot that's saying in the group is the only thing is these dot, dot. So if I run that, and I'd have to look carefully, but I think I got the same thing out, right? Okay, and you could move that sort of here, or I would often, if I'm gonna have a multi-line thing, write it like this. Either way is fine. What if I did this, which is one of the indentations that's supported? It turned out that would not be the right answer. That would move the dot, dot, dots into the same group. It turns out if you start an indented line with an operator, it continues it, right? You should not have to worry about that, but you might stumble into it, right? Because you won't need it. We'll keep things short. Okay, but that gives you a sense. There are some subtleties to the notation. And if you want to know more about the subtleties of the notation, the document, the section that you jump to the end to get to the exercises, it has a summary about all those rules in the middle. Right? But we're expecting you to use it for now, mostly like how most programmers we expect to use it, which is just assume it does something sensible and work with it until you run into one of the other corners that gets confusing. Okay, you do need to know a little bit about the shrubbery concept though to move forward in the metaprogramming thing. So we don't expect most rhombus programmers to learn about shrubbery right away. I use this in my class, and the juniors, it's like several weeks into it that they start wondering about these kinds of things. All right, are we all on the same page again? Let's look at the next part. So now we've got a foundation that we can write down some pieces of text, but get it into shrubbery form and then rearrange the shrubbery. So I need some more terminology, which is, I'm going to use the word parsing in a specific way, and I'm going to use the word reading in a specific way. And these two things together are what you might normally think of as parsing, like getting from text into the AST of a language like rhombus. Reading, again, this terminology comes from Lisp. Reading is going to be just the shrubbery layer. Right? So everything gets read, in this technical term, before you start trying to consider the syntax of functions and so on. And parsing is going to be the process of going from shrubbery to some AST. Right? So again, parsing, very generic term, but I'm going to use it in this very specific way to mean after you've got a shrubbery going into the AST. So you start from text, get to shrubbery that you might represent as S expressions, but it's represented somehow internally. And then in the end, you get to some AST like lambda calculus or something like that. Right? So the goal of running to run a rhombus program, you need to parse it down into some internal AST that you don't necessarily look at, but it's something like the lambda calculus on the inside. You may wonder, what are the actual primitives that we're going to be parsing into? What is this AST? and I'm gonna tell you it doesn't matter, like, there are things that come from the rhombus, hash length rhombus that are primitive, but many of them just expand into other things. So the simple view for today is to say everything that's hash length rhombus provides, that's the core AST, even though that's a huge language. But it's good enough for our purposes today because we're going to expand other things into them. Make sense? Okay, so we are going to start talking now about how we can parse different things other than core rhombus forms into those core rhombus forms. Suppose, for example, after you've seen that in Terp 1, you probably, if you have any ML experience at all, wish you could write it this way, right? With the data type, extra, and then those things that were similar to the class, but just written, and we have the vertical bars to emphasize alternatives and so on. So let's implement that. Let's implement this form. Okay, first of all, what is in general the pattern here? It always starts with the word data type. Then there's always an identifier like expert, and then there's always vertical bars with a set of options and so on, right? So here is how I would write the pattern. I'm writing a pattern as a shrubbery form in quotes, right? But we're going to use this in a pattern context. So this says literally data type, $name. So match any name, match anything for a name. Turns out we're requiring a single term here, like an identifier. And then vertical bar, dot, dot, dot. This is a lot like putting dot, dot, dot after a comma. It means repeat the vertical bar any number of times. And then we got match any name with the variant. We haven't actually said it has to be a name here. We just said match anything is the variant. And then a field, well, we got a lot of dots here, right? So why? Because of fields like fun, double colon, expert, that's 3 terms. For now, we're just gonna like match any number of any terms there. And then we have comma dot 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 means that repeat any number of fields that way, comma separated. You think about it, this dot dot actually applies to field 3 also, right? So field here is a repetition of depth 3. One of the repetitions is within the group, one is the multiple groups that are comma separated, and one is each variant. Meanwhile, variant is also repeated, right? Variant is a repetition of depth 1. Does this make sense? I think we should try this. So let's go over here. So here I just got a simplified version of our example data type call. I'm just defining input to be that as expression. And then I'm going to match using the pattern we just wrote. So this matches the pattern that we had on the slide. And then I'm matching the input against that pattern. So this match just has one case, matches could have multiple cases. So if we do that, then we want to know, does this input match? And when I run it, it says, yeah, it matches. So that's nice, but we want to do something with the pieces we matched against. So far, so good? Right. Let's not just, well, let's see. We'd like to generate things. Getting ahead of myself. I'm going to change this from match to use def. So I've just flipped things around. I'm saying define the variables in this pattern to be a match to input. So it turns out every time you write define or variable binding in rhombus, it's a pattern matching position. Okay, so just like I can say def x is 7, that's actually pattern matching 7 to x. And that's how x gets bound. So I could have said define x colon y, x comma y is at this 7, 8. That would be a pattern matching definition. This is just a big pattern match. So if we do that, it didn't crash, so that means the pattern did match. I could look at name, for example, and we would find that name really was matched up with the syntax expert, right? The identifier. Everyone still with me? What about variant? I try to use variant by itself. What happens? Variant's not just one thing, right? It's many things. But I can't just say variant by itself. I get an error about trying to use it on a repetition. So I need to use my repetition by writing dots. So now it'll tell me, oh yes, okay. variant is instantiated as this repetition. Yeah, I created a new list. So variant wasn't originally in the list. It doesn't matter, right? It's a repetition that I used to build up this list. And what if we wanted to do this with field? Well, that's the first layer of repetition for field. And another layer of repetition for field. And then one more layer of repetition for field. So we can see that field was name and column and symbol all together. And then in this case, we had two fields, and in this case, we had two fields. Right? Any question on this? And if you keep nodding, I'll keep going. Okay. Well, this isn't what we want to produce, right? We want to produce classes, just like was in Turk 1. So,
Matthew, excuse me, I have a question. You have
Yes.
to be very quick on the definition, but when you have a def which is not followed by a column, it's not a pattern.
It is a colon.
No. So the def input,
def input.
yeah, it is not followed by a column.
There's a column right there.
No, at the end of the definition. You know, online 11, you have a column at the end.
Line 11. Oh, sorry. So that's defining input to be the right-hand side.
Yeah, so this
This
one
is the left-hand side.
Yeah, I understand. But you said that anything after a def is a pattern.
Sorry, the syntax is def, pattern, colon, expression. So this is a pattern, and this is a pattern. And this is an expression, and this is an expression.
Okay.
Good question.
Okay.
And if you have a single line, often we write equal sign instead of colon. Either is the same. But if you do multiple lines.
Different shrubbery, but.
Different shrubbery, that's a good point. It's a different shrubbery. But the syntax says you can use either of these two forms, like the syntax of the rhombus line.
Different shrubbery, same answer.
Eventually, yes, yeah, exactly.
Right.
Okay, so good questions. Any other? Instead of getting these lists and everything, I want to produce a new syntax object to drop in place of my definitions, right? So that's what I've got commented out here. So here, this is an expression. Quotes in a pattern position mean match some syntax pattern. Quotes in an expression position means build up a new syntax object. So we're going to build up one that has a class declaration inside of it, using that name. And then non-final, just like it said in the interp line, because our classes are final by default in Rhombus. However, extends the name each variant with its field, right? And we got enough dots after fields, we can check 1, 2, and then this because it's on its own group, right? In its own group means repeat the previous group. That's the same rule as comma, and commas are separated groups. So if I run this, then we will get out those definitions just like we had them in an interpret one. Not as many new lines as you would have written, but you can ask it to print prettier and get some more new lines.
Command Shift L.
What?
Do Command Shift L and try again.
Command Shift L does what? Oh, okay.
No, I run.
I
Oh,
think,
no, too bad.
yeah, I don't know why. Yeah, let's not
Maybe there's a
do this
memo.
much. Great, okay. So that's what was on the slide here too. Make sense to everyone? And this is why we wanted to emphasize dots, because it's so handy when you're reorganize this. It does feel like an awful lot of dots, though, doesn't it? Especially right here, these are easy to forget because you think it's just a field. I wanted a field. So in fact, you can write it this way. When you have an escape that's by itself in a group, again, I warned you need to understand groups and terms, right? You have this escape that's by itself, it occupies the whole group. That means you can match a whole group as well. Okay. So this will still match. We can go back and do this and here I'm going to change my pattern now to have one less dot there and one less dot here. It all works the same. And if we look at what are the individual fields, so 2 layers, you can see at the end here we have these syntax objects that have multiple terms inside it. The whole groups. Each of these quotes has exactly one group inside it. It's a match the whole group. So this is a convenience that makes it much more attractable to write these things without explicit grouping everywhere. It's also a potential pitfall, right? You have to know about the rules of when identifiers can match a single term and when they can match all.
Yeah, this is, if I understand correctly, this is subtly different from the previous one because the field is actually matching something slight. It's matching a group and not a
That's right.
term.
This field
And
is
so,
matching name and the sequence, name, double colon symbol.
in particular, if it was exactly the same, I could put ... after one and not the other, and that won't work.
That's right. It is, it's matching the same things and I'm using it, but if I mix up ... if I say, then it'll complain about, why did they not highlight? Well, we'll fix that one day. But it should have highlighted this and said wrong depth there. We've given it 2 ... and it means 3 depth. So you're totally right. I changed the meaning of field when I changed the number of dots. But it happens that the 2 different patterns match the same things. Okay. Let's see my notes. Okay, so we're still on. Well, here I've done it kind of interactively, done a pattern match and then shown you how I can construct the result. We can package this up into a function, right? So here's my expand, which is just a rhombus function. It takes an input as its argument. It matches that input to a pattern, just like we did at first. But this time I put something more interesting in the body of the match. Instead of just saying, yes, it matched, then I put that template construction. So it does the same sort of thing we were doing before. If I run this, then my expand turns this syntax object into this other syntax object. Feels like we're most of the way to a macro, right? We've got something that takes a shrubbery and gives you another shrubbery that's the expanded version of that shrubbery. So what's missing? Why is it not a macro yet? It's just a function, right? So if
the thing that it expands.
yeah, if I tried to not put it in quotes down here, it's like the function doesn't exist yet, right? So it can't expand data type. So I need to put this function in a place where it exists earlier. It exists while I'm trying to process the module. And I need to set up some connection between the name data type and the my expands like function that lives at compile time. Okay, so let's take the compile time part first. I've changed hashlang rhombus to hashlang rhombus and meta. So this means I want to write runtime code and some compile time code all in the same module. I could equivalently have written it as hashlang rhombus and import rhombus meta. And open that up would mean the same thing. It's just because I have to do that often enough, we make a shorthand language that combines those 2 things. One of the things it gives me is this meta keyword. You can see here. Meta is kind of like a block, but it says move this block to meta time. So that's what we call compile time relative to runtime and expand time. Let me get these words right. I think I have a slide that tells me to do that. Right. Okay, so runtime is when you run your program. Parsing is what I told you I was going to call converting shrubbery into the AST, right? You might also call that compile time. Or you might say expand time. And I use all of these words, and if I slip up and use the wrong one, they're all interchangeable anyway. Okay. So that's why I use, yes.
Are these the only phrases for rhombus?
Well, no, you can have meta compile time and meta compile time and so on, but these are the 2 we're going to focus on. Yep. When would you have meta parsing time? Well, if you want to use macros to write your macros, which of course you do, but you don't think about it that way all the time. Okay, so what's going to happen when I run this program?
So meta means +1.
Yeah, meta means +1.
Really what it means. It doesn't mean 1, it means +1.
Yeah. I'm going to run this program, and what you're going to see is parsing prints first, even though it's later in the file. Right? And that's because parsing ran earlier. The printout of parsing ran at parsing time or compile time, and then later running. If you do this in your Dr. Racket, you may in fact see parsing twice. It seems that I've turned off debugging in my Dr. Racket. So the debugger in Dr. Racket turns out to parse things multiple times as part of its strategy. So you could see parsing any number of times, but you better see running just once when you run the program. Okay. The order is the key thing here.
Yeah, it's emotional, it's how to say, kind of the read modules in commandments.
I think it's related, yes, yeah. Okay, so this is how we could put our mycompile function into meta time. That would get us halfway there, but we would still be missing the connection between the name data type when it appears and running that. So let's resume. Okay. Something reminds me. I think I had another file I wanted to open, so let me find it. Try one more time. All right, I can't find it, so I will just redo it.
You said the parsing should only print out once.
Oh, no, this is what I wanted to. Sorry, here, no, parsing may print multiple times. If you have debugging turned on in Dr. Running should print once. So in general, we think it's okay to compile a program multiple times, but if you ask it to be run, we should just run it once. Okay, sorry for just not being able to read my own file. This is indeed where I want it to be. So here, instead of meta and fun, I'm using defen.macro, which also comes from here, although again, the error is missing. But you see, it has the pattern built into the definition form. Because usually you don't want to write, I'm writing a compile time function and I want to do a match, just put it all together. Okay. And the other advantage of putting it all together is that def and macro can see that data type is the thing you're defining here. So this is actually a definition of data type. That's why the arrow is drawn that way. And it's just fusing the compile time, or it's parsing time, match of the pattern and generation of the template. You can put any expression you want here in the body of def and macro, but I couldn't just produce this template right away. We could print parsing here if we wanted to or something. And now, even in the same module, we can affect how data type is interpreted. It's going to turn into these classes, and so I could have a little mini interpreter there that works. I can do a terp of ID X and an environment that maps X to 5, and that'll work the way it's supposed to. Okay, so all the pieces that we've been talking about finally add up to this metaprogramming step. I think we're at a point where it's time for you to try again. Yeah, so go now to the notes, to the post-shrubbery parsing form. So you're talking about section, and at the end there's an exercise. Yeah, one exercise here. So you get to look at that interp version, interp program again, where it's already changed. Let me just download it. Yeah.
You can talk about annotations.
Yeah, I didn't talk about annotations today. I didn't have a slide for that, so I forgot to talk about annotations. Do we need?
Just go for it.
Yeah, we're beta testing the tutorial. What is the exercise here?
Fix some error syntax errors.
Oh. It's really the exercise is supposed to introduce this.
Okay.
It just tells you how to do it.
Okay.
Just to be clear, it's saying if you change this to a 7 in a place that doesn't make sense, then you get a bad error message because it's talking about class. And no one wrote class here, you wrote data type.
Also, it's not just highlighting the 7.
Also not just highlighting. Good idea. So the thing we're debating whether I should have explained to you already, and probably I should have. As you can see, instead of $ name, it says $ and then parentheses, name double-colon identifier. So the identifier there is a syntax class. That's constraining what name can match. You can only match identifiers. So. We have no such constraints on the fields.
Before it was always $ identifier, and now it's $ open parameter.
Yeah, it used to be
So that's
$ name.
Space to put the.
Yeah, and now it's $ name identifier.
I think it's here. It's one system.
Yeah, follow the flag. Yeah.
Well, that's not quite right. That's not very simple. Yes. So this annotation, but it's kind of what I take description, but it's supposed to be inside this statement. It's you're not saying. A field followed by action, literally colon followed by the word identifier. So it's so you go to so it changes. I think there's we can do that, it's supposed not to be on the. Yeah. Some things don't like this. Do you have work? How's it going? But it's very. I used to do.
It's supposed to kind of annotations. It's part of the pattern matching.
It's all obvious. I mean, it's just there's a lot of it.
Exactly. I don't know.
Yeah.
They're on the slide.
Okay, so but did you choose this?
Yeah. So this means the $ applies.
I think many of you are here, but if you want a hint, this is the region of where you're changing.
The $ is common.
Because that's just matching anything and passing it on to
The comma
class.
is only.
You can be more specific.
You want those description thing to be connected to field.
Yeah.
It's one of that. So you have to use something like that, so that will be in trouble. Yep, and now this $ is over.
So the solution is not just to use parentheses and try to name a syntactic constraint. You could do that, you could define your own syntax class to do that. And that would be the way I would do it in many cases. But here I could also just say, I want field to be an identifier. And then totally different double colons, right? This is a literal double colon that I want to match. And then some other identifier for the after that.
Yeah, okay. Remember they said.
And I observed that you're using double colon instead of the more conventional single colon, presumably because single colon is gonna
Exactly.
create a block.
Yeah, single colon is already very occupied.
Exactly.
So,
This one is an out. That's just a. At least.
Alright, so if I
at least
make
it'll
that
be three
change.
pluses.
Except I have to use different names, of course. But I have to use it in the right way down here. Then I get a better error message, right? Data type is now complaining. And how can it be that data type is complaining? Because it's the pattern, that part is built into the data type pattern. So the matching machinery knows the right context to complain about. So this is something that happens with macros. Sometimes you can just pass things off and leave it to the lower level, but often to have a good, well-defined syntactic form, you need to put all the details of your match there. You might want to abstract in it by lifting them out into syntax classes that you make your own, but that's a practical technique for getting good error messages in reporting. Okay, so hopefully you had enough time to at least try that. Let's go into the last piece that we expect to get to today, which is enforestation. So parsing so far, you may have noticed actually we made it a little easy by doing definitions, which always have the word at the front, like data type to start it out. But what if you want to do something like plus or times where the operator is in the middle? All right, now it's not going to feel a lot more complicated to get started, but this tutorial is about showing you getting the mental model of the underlying machinery clearer. And so in fact, we would break up parsing in something like an expression context into two sub-pieces, enforestation and expansion proper. So I've used parse and expand kind of interchangeably, and I will continue to do that. But if you have to implement this or think about it at a lower level, there are these intermediate processes that all get you to parsing. So enforestation is dealing with the infixedness and the precedence, and expansion is then just like we've been doing, rearranging those pieces. So here's an expression in Rhombus. This is a list, and I remove the two from the list, and then I use this pipeline operator, similar to F#, I think, in other languages, to send that to the print line function. Okay, but how does this get parsed, right? This is a bunch of the 1, 2, and 3 are clearly grouped, but everything else is sort of all at the same line, right? So we need to parse 1, 2, 3, and then we see a dot here, and we don't want to parse an expression after that because remove is not actually an expression, right? Remove is the name of a method. So it's sort of more stuck to the dot, and we let dot have control of that. So that's why one reason that enforestation and expansion are interleaved. We do enough to get to dot. Dot decides it wants this much to make a method call, and then it leaves the pipeline print line there for enforestation to take back over to discover that there is in fact an infix operator that does want to parse its right-hand side first, roughly speaking. That kind of interplay is what you need control over. Everyone see where we're trying to get to? So let's talk about how this works just a little more practically. So I'm going back out of macro world now, just a sort of regular Rhombus world. Function definitions are clear on that, right? Function rev list takes 2 arguments and build a reverse list out of them. Okay, so when I run this, you see banana apple. Here I'm doing the same thing, but with an operator, less than, tilde, greater than. Then I'm making an infix operator. And it's this operator form that's built in just like fun is built in. It knows how to let you define infix operators. So there's apple, banana that way. This operator does not have to be at the top level. So I could do like a list where I locally defined the operator one way, and the second item of the list, I define it the other way around here. Let's not make it reversed in this case. So the point of this is not that you would normally, oh yes, I need to use the operator. After I define the operator, I want to use it in this block. And the same thing down here. So you can see banana, apple, and an apple, banana, because I defined the operator in a different way. So the point here is not that you would normally put operator definitions in the middle of your list, but that there are other cases where you have expressions with definition context on the inside, like lambdas, right? That kind of function. So enforestation and parsing need to be interleaved, right? Just deciding that this operator is an infix operator of a certain sort was a local definition and needed to be handled before the rest of that block could be parsed. So you don't have to worry about that too much, but it's good to have in the back of your mind, you know, this generality is why certain things work in certain ways. So let's not do such crazy things. Let's look at this case. Right, plus operator is append and string append in this case. So we should see apple pie and banana cream. pie, but banana cream cake rather, first, right? You may have noticed there's some parentheses there. Yeah, what if I take them out? Right, who thinks this should work? Dylan thinks it works because I told you it would work, but why not, right? Well, a priori, who's to say which of these operators should take precedence, right? Nobody said, and in fact, you get that error message. So the way you resolve precedence in rhombus is just locally, you can say this is stronger than, actually weaker than, plus plus. It get a little tedious to write out all the operators that you're weaker than, right? We tend to group these up, and plus plus declares itself to be a comparison operator. So it's probably not comparison. What is it called? You can look at my notes from this. I could go look at, oh, it's called concatenation. Oh, because it's not a comparison operator. There is a comparison operator set, but of course plus plus is not a comparison. That's why I thought it was. Concatenation is what it is. So it declares itself in the concatenation group. And I could find that out by going and looking at the docs. I just didn't do it. Okay, so nothing surprising here, right? Precedence in rhombus turns out to be a purely relative concept. There's no total order. You don't map it into numbers or anything. It's all individual case by case, which can be very flexible. And it also means that when things don't make a lot of sense, they don't have to make sense. You can just tell the programmer, you need to put parentheses around something for this to make sense. Right? Often this happens with comparisons getting mixed up with arithmetic and boundary or something. Okay, so.
Would the ordering understand transitivity?
No, it's not transitive either. It's not
Okay,
an order.
so if I'm
It's not
weaker than concatenation, I'm not necessarily weaker than things that concatenation is weaker than.
That's right, yes.
Is there a reason why you didn't want to build that in?
Well, then it has to be in order for this to make sense, and in general.
It could be a partial order.
Even a partial order, it's not a partial order. Yeah, so we're following Fortress in this case.
Okay.
Doing what Fortress did, and it's worked out well for us. Good question. I don't know whether it would be better, but this has worked out really well.
Okay.
A lot of the traditional problems you have with precedence goes away when you don't try to make it an order. Like the certain confusing examples, you can say, well, even though an order would imply something for that, we can just phrase an error instead. So that's what I mean by it working out better sometimes.
I'd be interested in the order versus partial order
Yeah.
trade out, whether partial order also solves the problem without having, because with this, you're gonna have to put a lot of less than and greater than sometimes, right?
You might have to list a lot of, yeah, usually it's only 3 or 4 that you care about. It's like,
Yeah.
that's what we're finding,
Okay,
is that we don't care to declare how it works with the rest of the world. There's kind of 2 categories. There's one where it's like arithmetic, where you say, I'm relative to these few other things. And then there's the other which says, I'm just weaker than everybody else, or I'm just stronger than everyone else. And that covers the vast majority of what I've done. Yeah. So that's operators, but we're out of macro world, right? Let's go back in the macro world. X for macro is the form that will do that. So let me go to the next example here. So this looks kind of like a hybrid of operator and definition macro. So it's X for macro now. For an expression position, we've got a pattern just like we had for definition pattern, but because we're in the X for world, we're allowed to put what we're binding in the middle. Right? And how does X for macro know where to look? You know, there's some rules about if you start with $sign name, then that's a pattern that you can match to anything. So what you're defining must be right after that. So it's defining the infix operator, this time with more tildes on the inside, just to distinguish it. The precedence declaration is just like it was for operator. And here I'm taking advantage of the fact that I'm writing a macro instead of something function-like. I'm actually going to evaluate the second one before I evaluate the first expression. And you can't tell if I just put apple and banana there. This expands to this big block and then it makes a list. But if I add a trace function here, so trace has a side effect. And if I use that side effect on both sides, it's just kind of a contrived example here to show that there is some order of evaluation that we're controlling there. I did it with a block to make it explicit. It turns out if I just put $B, $A, it would also have the effect of ordering it this way. But that's why we would want to write a macro instead of just an operator. If we needed to take control of our evaluation order, or if it, just wasn't two expressions being used as is, there was some binding involved, or if one of them is not even an expression. But otherwise it's the same idea, right? And it's plugging into the enforestation machinery in the same way. Any question on this? Okay. I mean, if you start to think about this, like, how does it know how much to use of the left-hand side? Right? $A, when we wrote it before, just meant matching a term. But that's not what it means anymore, right? This is not a single term, this is actually a whole expression, a trace function calling here. Right? And why was it happy with the precedent? It's because function calls said I'm stronger than everybody else. So it turns out that these patterns that we're writing after X per macro are not quite the same as just the raw patterns we were writing before. And the way you should think about this is just X per macro pre-processes the patterns in certain ways. And what it does is it says that when you have just $A to the left of the operator you're defining, treat that as match any expression. So it makes the match more general. It implies that the enforestation machinery is deciding where the expression ends. But it's also making it a lot easier to write the macro. Right? So if you're interested in more of these details, like what is it that this elaborates into in some sense, what is the pattern if you were writing it with the volatiles, then we'll let you go through more sections of the tutorial on your own after, and I'd be happy to answer any other questions you might need. But let's see, we have some more things we could talk about, but we'll go back into to exercise mode for the remainder on the operator stuff we just saw, but just so that we all get to the stopping place. If you're interested in the last pieces, we did about half of the tutorial material. And so you could look more about bindings versus expression macros and how that interplays with the patterns. You can look more into implicit forms, which is how something like 7 gets a meaning. If it's just 7 by itself, there's no operator around it, but you might want to control the meaning of numbers. Okay, so there's implicit operators you can bind. And then when you have that, it turns out you have enough that you can make like your own standalone language that's smaller than Rhombus, say, and that has completely different things. So the tutorial shows you also how to do that. But meanwhile, I encourage you to go to the enforestation section, and there's a couple more exercises to do that will let you play with these things, and we'll walk around to answer more questions. Other questions? Yes?
Are you back in here after the break for the second half, or?
We were planning to start from the beginning in the second session, since they're parallel tutorials, and they asked us to run it that way.
Oh, I see.
However,
Okay.
if you want to keep going and ask questions while I'm not talking, or ask Robbie, then we're happy to do it that way as well.
Yeah. So
anyone who wants a double dose, or to do twice as much work, we're happy to keep talking to you. All right, so it's 4.3 is the exercise where we are now.
Yeah. Valuable.
But it's an identifier. One of the guys does something else.
And what is the no arrow because okay, and how do I know that these two things are not the same? How do I know that this is not the line?
It is very. Oh, it's in boundaries, not a fighter.
Yeah.
How do I read it? It's fine.
Okay.
Yeah.
So it's there.
Shrubbery and it's representing as patterns.
Okay.
And then that's patterns.
So
You mentioned species.
it's the question: how do we get all this up?
Yeah. I think if this shrubbery, nothing else knows about dollars.
Yeah.
And because there's a dollar sign.
Well,
there are
that
dollars
is following through.
Yes.
So that means copy that. This
Well,
dot
yeah,
dot
dollars
right
all
after a comma
parentheses.
means copy all of that.
Identifier, colon, and a reference to this index class.
Okay,
So
so
that's why
this is
it
because
feels-
common is a special thing. I'm not matching something which is
So that's what we
valuable and something and another valuable. This is the syntax, this is the meta syntax. Okay.
It's the dollar sign.
Okay.
It's the dollar sign that's in the context of the pattern match inside the syntax.
This is about
First
the,
off, but like just.
so it means that how is different dollar is built.
No, three.
It's a,
If I try to use field bias.
Dollar is a
Because field
thing that
is
can
not a
appear
variable.
inside.
It's not just one value, it's that right.
It means escape.
Repetitions of that.
Yeah.
So fields.
And if you put, so for example, if you put.
And to use field, I have to use it to that's actually that.
Now this is like definitely macro. This is a pattern. And it goes to this dollar sign, it's like, this is not a thing we can put up here.
So not really.
but, okay, I understand that, but my question is how is dollar defined? Where is it defined? It's defined as this
It's a
module?
struggle.
Yeah, I see. Yeah, okay.
Now let's say
Dollar is at
this.
the heart of the pattern match.
It's nine. X.
I understand, but I would like to see the definition of that.
Individually,
How is it defined inside this rhombus and?
as soon as I write this, when I
That's the
try to run it,
definition you are. That was the. I would like
it's
to
a
see the
connected
pattern
expression by.
that is down.
So X doesn't mean just one.
Oh, I see, because you want to use dollar and you want to know what all the knobs are for example.
Because I don't really understand what I'm doing. You know, in the first place, it was not obvious to me. But it was not just a regular pattern. It was three things which are just variable.
Okay, as long as I use that.
You call it operator, I think,
Yeah.
and another variable.
I have a list of it.
It's, so, okay, so in my analogy of scheme, when you put a comma, it's
Okay,
actually.
this is still
the
okay,
reader
just when two
turning
checks,
into
this is
open
the
line.
key that does.
Yeah, and go.
Unquote,
yeah.
but that's not happening.
One match X to the individual pieces of.
Instead, it's already a shrubbery. The dollar sign is already a shrubbery. And it's just the def and macro is saying, okay, I want to treat this as a pattern.
This set.
In the pattern, it's like all space of Yeah, but patterns are space like.
If I really wanted to flatten it out,
Around
turns out.
And so the
And that
dollar sign
means
part of that.
kind of a special case, it means sort of flatten things out. So that'll put our, but you guys.
I'm trying to understand.
Like what part of thing is the same as like that.
How we leading some,
Yeah, so this.
It seems that there sure, it seems that there are a lot of implicit things.
We just lifted it up into the basic.
The rhombus is mathematical. A lot of the same kind of fundamental idea. In the.
So it's, yeah.
A lot of things.
Is that useful?
Radical.
Yeah. Okay, good.
Yeah.
You use bracket or rhombus like before?
Probably.
A lot of bracket, okay. Okay, great.
You know it. looks
Where are
like
you
that
from?
in some versions, so probably you would do it this way. It
So
just-
you're.
Yeah,
Yes.
there's a lot of that.
Yeah, I don't know how it works. I mean, probably if you have practice with that, it's a convenience, but it's maybe difficult to get used to it. I don't know.
I mean, you have
it.
You have to just be free.
Absolutely, no, I'm just asking for myself, trying to understand what else this is, what's right there, like, but I think.
I nowhere near as many advice. That's what she said. That's good. He's still young. But yeah, he feels very much like just.
No, but it's fine, it's between which sense, I mean, it's.
Don't worry.
Controller or it's. That
That's
like different,
It has a couple of hesitates and a couple of issues.
okay.
They kind of be free. And then, I know, some weird thing happens and then you have to understand a little bit more. But that's also, again, this kind of be free motto is that you can take a bunch of steps without having to go, you don't have to learn first principles all the way through. you're just gonna like get jobs done. And then later, you can postpone the time, which is so understanding everything.
Yeah.
And some things, you have to know about deforestation, you have to know about shrubbery. Or you can do anything. But many details, are just kind of say that you can set a lot.
We're happy to hang out, but definitely know you've earned your break. It's a good show.
It's difficult to organize all these things because if you enforce something like this own pass. But when you keep thinking about the question, I was thinking about this thing, about the dollar thing, and it was thinking about the other PlayStation. Yeah, sure.
It's hard to. Yeah. It's all written, actually.
Yeah, no.
I think exercise 4.4 is one of the hardest ones, but I think it's the neatest.
Yeah, it's yeah. But yeah, it's the one we let people.
Yeah, I did. As I mentioned to Robin, I was just talking some question about pattern before with this variable column in a file.
I don't know how you put it.
Yes, you did. And I was thinking about it, right? Realizing that I have not understood exactly what this is done.
Yeah.
Because I was surprised that identifier is something special.
Yeah.
Not seeing the definition of the thing.
Yeah.
And because I was thinking about that, I have not really been able to follow what you said with the enforestation.
That's it. Okay.
But it's a difficulty of tutorials.
Yeah.
Not everyone is able to follow exactly at the same rhythm or path that you are enforcing.
Yeah.
And
So it turns out alpha dollar sign is a new kind of thing. It's an unquote binding condition. So you can extend that.
as I mentioned, throughout for me, what would have been helpful is that it presents the definition of this dollar thing, how it is defined in the library.
Yeah.
So that I would have been able to understand, yeah, okay, it's something.
Yeah. It's easier to, after the next section, it's easier to do that, right?
Yeah.
When we talk about spaces, that there's expressions and binding.
Yeah, I tried to say something about how we're sort of the anti first paragraph of our aesthetic. This is one way to.
That's a useful.
But
Characterization.
we remind you of, yes, exactly. You know, we're experiment, you know.
Yeah, because it's not that I'm complaining about anything, but instead you start very slowly and you can elaborate just on the top of the thing you have defined. And here it's different because there are some implicits that you cannot implement.
There's also, it's exactly, there's also just.
And it's
Starting from a much bigger spot.
And actually what I found nice to follow in the tutorial is what is implicit and what is explicit. Because for someone who is new with everything, you don't know in advance. Syntactically, it's not so easy to spot that, yes, this is just an elaboration of something that has been presented before, and this is in. And maybe if you have to
Scheme perspective too.
Yeah, absolutely. It is. Yeah, it is.
Yeah.
But anyway, yeah, it was very useful. Kind of a sense of
anything
not in the space of design and trade-off. Everything is explicit, everything is many things are implicit.
Yeah.
And so yeah, no, it was very nice. Okay, thank you.
This, I mean, you know, I remember the exercise of asking this. But this is the thing, this you'll find this.
What's the function to turn an integer into a string?
And integer and string.
So they just interleave, you know, so it'll expand it and then now I have to call that one. So then that one, that one's. So this will do a thing. I don't remember what the exercise is asking, but it doesn't break things according to that.
You were supposed to print the. First.
Oh, I see. Oh, I see. Yeah.
But,
It's not in my.
Oh. Okay. I was fooled by that.
Yeah.
Yeah. I guess that's a hard question. in language that's functional.
Now I'm going to you can just print.
Yeah, so I'm close up to the string, which I noticed before.
Yeah, what I will
Get
do.
rid of that.
That's what I guess. Are you doing this?
You can just put it on there, yes. Now that's gonna, that's what they actually.
This show line is executed.
Expanding into something that things come out, that would be let's,
Right.
cool,
Which is fine.
this way is easier. So just put this is not the correct solution, but just to
Well,
illustrate the point, you could do, this is what it's asking
Let's see
for.
what that.
Yes.
This is actually, so now, line 4 is gonna execute and log as is. Then, and then 5 is return what log as.
But if you wanted.
Yeah, you said something and
I like your way, I wanna kind of try doing
that.
that. I didn't try to solve it that way. Matthew might know off the top of his head.
Yeah, we're working.
Actually, it's instructed to track it out. You know how it is.
Yeah, of course, values. That's right.
Any questions?
Oh,
No, it kind of is special. Okay, the expression looks really weird because it's.
right, yeah, no, the where the problem was. But.
So the first string, the first string. The string.
Right, yeah. It's fine. Oh, what, right, but I still wanted to. Okay, so now I have an extra parentheses.
There's a lot going on.
And, oh, I don't want show on, I want that. Probably don't want us. So show myself.
So it's adding extra quotes. This is.
Show is adding extra.
Yeah, show and.
Oh, because show is,
Let's study there.
I don't know, actually. I don't know.
It's like, it's like tonight. It's probably-
Yeah, so it's one.
something else.
I happened, show was because it was, looking for another right place. Okay, cool.
Print, so print, prints, like, where output and shows your like a value.
Yeah, okay. So are all the tutorials like this where? Right. They're the two chunks that are the same.
That's what they ask us.
Alright, so if people are.
Yeah, and pulling clone, literally be pulling clone to the yeah, so when this comes in, I see.
Yeah. This one's so, I defined to be financing, that's.
What are you using in this?
Now, I use things.
So it was a sort of.
You measure this is.
It was in there.
And I was able to go from it. So that's like not from like the usables.
Yes.
Plugging in. Yeah, it's a bit of client on this.
Yeah.
Oh.
Yeah,
Exactly. Oh, my. You can still browse the internet.
yeah, so the term means storage.
Oh, okay.
Alright.
Thank you. Yeah. I think I do. I'm looking at others.
Is that?
Yeah. Although in this case, we went at direct.
Well, it's from that, all that, don't need a copy.
Yeah, that was it, thanks.
Expand. It's like, oh, I didn't try to solve that, I thought I told him one. And, not what you, something like that. Solve it that way. Sorry. They follow the travel.
Oh, great. People did again. I hope you will want people attending the second session, because it's confusing to this parallel
Yeah,
session.
sure.
And, but anyway,
Yeah,
well,
we'll see.
for this one.
Yeah.
So,
Good.
okay, so see you, we meet after the session for having lunch together.
Yeah, sounds good.
Lunch is here, right?
Lunch is here.
Okay, so see you later. Thanks.
Okay. You continue in this tutorial? Or continue helping the second, or just someone else swapping?
I think I'm still here, I'll double check the schedule.
Okay. That'd be great. Boring for you though, because you're seeing.
That's all right. Yes, I am here until, looks like 2 o'clock.
Okay. What are we doing? We're away in Zoom to make a different key, show the set of escape, because I'm all the time hitting escape for Dr. Reckon. And then the Zoom window pops up. All right, see you soon.
Very good. Should I see what this was actually spitting out? Oh,
Vegetable dumplings.
chicken and egg sandwich. I would have gotten desserts, but the brownies had one that's on top.
Alright. Where you going to next?
Oh, I'm gonna go get some food first and then look at the schedule.
Have fun.
You too.
Okay. This is not the same as this. No, it's not. What is? This is not so bad. Oh. Yeah, that too. Yes, yes. Yeah, so it's out of April. Yeah, yeah. It's like. One that, yeah. 9 AM, 11 AM. Yes. Yeah, so it's probably this one gets straight. Yeah, exactly. Yeah. Yeah, right. We saw. Yeah. Right.
There we go.
I like you too. Yes. See you around.
I don't know that exercise.
You can do all the exercises with the amount of time you got to sit here, right? You're
I didn't mean to interrupt you before you were saying something about the food.
Huh? No, oh, no, yeah, so David brought that to you. I'm gonna go right on the. On the. Cause it looks like, I'll show you. It looks like, rhombus is the title of the tutorial and something about open whatever, what have you, is the subtitle. But in fact, it's 2 PM and 4 PM and 9 AM. Only one door. Yeah. So I was looking at it like wrong, I was like, someone just put the wrong subtitle on it. No. It's not. Okay. So people are supposed to be back in here in 10 minutes.
Yep.
Okay, we'll see. Many people didn't show up until like 10 minutes after.
Yeah. I'm hoping that's just because it was early in the morning, but who knows?
9 o'clock's not that early. I don't know. Are you from here? Or do you live here, I mean?
No. I'm Marco student.
Oh, really?
Yeah.
Oh, okay. Nice to meet you.
I'm actually applying for your PhD position. I work with you and Christos.
Oh, you are?
Yeah.
Did you send email?
Haven't sent it in yet, but I've gotten a video call Christos talking about
Okay.
it. Yeah.
Okay. Because I remember Chris was talking about someone. Yeah. Oh,
Nice to meet you.
Yeah, same. Yeah. I didn't remember your name though. Yeah. But yeah, Seton Hall. Yeah, cool. Yeah. I feel like I was going somewhere with what we were talking about before, but I totally lost it right now.
Sorry.
Okay, no. So I mean, no, I didn't mean it like that. Yeah, okay, sorry. Yeah, it came across that way. That's not good.
No.
It's all right.
It just I didn't take it like that. I'm just
Okay. Good. Yeah, well, I'm glad you got to this room then. Yeah, that's awesome. Yeah. So, okay. I'll see you in a bit.
Yeah.
But like subtitle, but I figured out it's not subtitle, it's actually like a title.
Did you write on this one?
Yes.
Oh, okay, good job.
Kind of jealous of you guys, you got all the sweet racket swag.
Yeah. You want a
Oh.
sticker? I have a sticker.
And ski.
This is old, this is a very old shirt. It's not considered the relative ages of you in this shirt.
Shirt is older than you, right?
That was close.
Actually, when did that occur?
2000.
No, like when I was born in 2000.
Oh, okay, oh, maybe 2000.
Yeah.
It would have been the summer.
You have a racket?
Oh, it actually is an
I
interesting
do not.
question.
There's two things, there's like.
Thank you.
Alright. We don't have enough stickers. None of my last one.
I want to save this,
Alright.
because this is a school laptop, I have to hand this.
Oh,
back.
okay.
I have a large stack of those, I just should have brought them. They just come to RacketCon, and although you wouldn't have,
You didn't have any racket?
didn't bring them to RacketCon, that was dumb. Yeah, I have like this many. Somewhere, I don't remember where they are though. What?
I think I've used all mine up, but Ben may have the stuff.
Ben,
Sure.
that would have been a good idea to bring them here, huh?
I know what I'll do.
So many things I forgot to bring. My flip flops, like what am I doing wearing shoes?
I'll put them on this one.
I'm trying with two laptops, that's serious.
Yeah, you're familiar with FSM? It's the DSL we work on at Seton Hall for
Okay.
the automata theory
Okay,
course.
yes, I have a passing.
Yeah, we have unfortunately there's OS dependent stuff now, so I kind of have to always have both on me.
I see.
No, nice. Good.
Yeah,
especially I see a non-Mac laptop. Is it what OS? Windows. Oh, okay, got that. Yeah, we're good. Yeah, you're good. You're good.
Sorry.
No.
If we had known you had a whole other laptop, we would have just.
Well, actually, I don't know if I have to charge. I leave it in here, but this is very, very cheap battery fed, so it always has to be plugged in to work.
There is a way to get on. We should probably get on how to get online. Do you know how to get online here?
Oh, you need the Wi-Fi?
Yeah.
Yeah, I got it.
What's my card password?
Go on to the NUS guest.
Just like you. That's right on that.
I haven't been able to get to the calculator.
Someone left here.
Yes, no.
Now, this is a work laptop, so it's gonna.
Oh,
lock
down in a liquor.
Yeah,
I know.
Oh, I don't.
I might.
Let me use. Oh. I'm gonna buy this one, but you see around it.
Pairing is a good idea.
Yeah.
I didn't bring my personal one. The last go, we had one pair and they basically always got all of it. All right, way ahead of everybody else in the room. So.
Oh.
Right, everyone, the hardest part of the tutorial is getting Rhombus installed.
And it's actually not that hard though.
It's not that hard.
It's an odd mix.
Yeah.
So what's the question was again?
Came up.
It's finally.
I don't even talk about anything actually, because I'm a so I might not be able to install it without it.
Well, so you can install Racket, right? You have to do it the long way, which is you install Racket. And then.
I have my personal.
Yeah. If you don't put in the piano.
Why do you advertise this? Completely different language, like if you pass this on the website, it's all part of the racket stuff.
We're experimenting with the right version. It's not part of the record install that I need to do anything. And, yeah, so having a separate library.
Oh, yes.
Nobody really cares.
How long you're doing installing? 5 minutes?
No, actually, and you will
Thinking you're installed.
No, this just says what it says like it's an edit to account email, so.
Oh,
That you just not correct it.
I think you just.
The bracket.
If you install it, we'll probably check it.
The roll, scroll down.
Yeah, which is
Yep.
No, it's right.
We're sort of.
It's not really.
I don't need that.
Maybe guys, it shouldn't take too long.
I guess I.
The snapshot is yet newer than but this is okay. But if you're gonna install something, I would recommend installing the snapshot.
It's just package going off the right. With the front and arrows. So what's the allow?
How do I conduct it?
You put that back there, I haven't mentioned it to them, so it's such a.
Which is.
That's not
You had it.
Oh,
Yeah, the best one.
You get that right?
I'm gonna try to do this just
Yes.
to not.
So under the file menu, there will be installed.
I see, I see. Yeah, it'll work with 8.18, so. Okay. You don't need the snapshot version.
Well, once you get things going, it's still work on your own for a little while, and this gives us time to sync. But go ahead and do the crash course exercises that you'll find at that webpage, with all the notes. So in the crash course, you are supposed to guess, you're not just supposed, don't go read the documentation, certainly, that would be cheating. But just to get a sense of what the language looks like and how it fits together.
Roll it from.
So you know, sure. Yeah. Okay. Well, official.
Surprising yourself.
Yeah. Oh, sure, yeah. Yeah, no, yeah. And then, yeah, of course.
That one is installed. Okay, so but that link will take you to. We recommend just installing the wellness snapshot, which is recommended.
Does it need any specific version of Racket?
Well, it's just, if you don't already have Rummus installed, it's easier just to install a separate copy of Racket for now.
Faster.
It's a little faster.
I have a version of Racket, so
Yeah,
the question is, I don't know
probably only
which.
switch. It'll have to be included.
But you probably need an version. Did you install? Did you install?
We're on mix.
Binary distributions just don't work. Okay, so maybe. Eight dot 14. Yeah. Okay, so now.
It's more serious.
This does not have to go for it.
Can you click on the menus?
That's what we said. You can do everything except the menus.
Okay.
So go to the command.
Yeah.
And just like.
You can go to command.
Actual command, not the.
The shell. Oh, yeah. Yeah, and then.
Already see you.
Right, yeah.
PKG. Not install. Bus. So that will do it.
You can provide public use. That means to download over at your room.
Yeah. So there is.
It's funny.
That's Matthew, is 8:15 too old?
8:15 will work. It's not ideal. It'll be easier. It'll just work.
Okay, I was trying to avoid the.
But now we're hearing this.
Yeah, that's why I was trying to see that. Yeah, we'll see.
Eight 15 turns out to be a special case. But I think it will work well.
What seems maybe is unreasonable only under certain assumptions.
Yeah.
Now it's
That's okay. So I saw this, I thought, oh, that's a fact. You can read the.
Oh, I'm not using Mixos, I'm just using like Mix, the package that you're still. Yeah, so.
That'd be the only one.
So I don't like.
Now what I've learned is when you do a tutorial at a conference, have a mix package.
Well, it's a good way to get started, but I think at least.
Post
instructions, the install instruction on the.
So all I do if I try to do Mac.
Yeah, the abstracts.
I mean, people will not all come, some will.
I just link it to the preprint, but it was not early enough, and the abstract is about.
It's probably a lot of copies. And then my computer's also, so that's maybe.
It's just the.
The racket installation, you just put it in the folder and then just throw the folder away later. Okay.
If you look at it, it's confirmed.
So it's similar, Nixian Makes you sure. I understand most things don't.
Yeah, that's fair.
But rec is definitely.
I'm sure it's a year.
No, no, it's okay. It's still be faster. I think we're starting now.
Oh,
Just because it's gonna be a little while.
Oh, okay,
Before we get there. You can do a race. This thing is gonna give you,
So it's actually happening, it's doing all the work I'm doing to make it.
okay. And then if you just put that on hold somewhere that you feel like throwing away.
If you get to documentation, just like, I'll see.
Okay.
Must be.
And so maybe we can race.
I'm pretty sure this seems like
Yeah.
it's just moving this stuff into my desktop like in my old floor and it's downloading at like 9 megabytes.
Oh, no,
Oh, no, it's
library. Yeah, that's the next thing. Yeah, something's wrong with the dependency.
No. I was like, how they on this has ever gone so smoothly.
I generally is not trust.
And I think that would actually keep you from starting back around.
Okay.
Yeah, so if you just put this in the desktop, and you don't have to put it in the applications, you can put it anywhere you go. And then maybe even you can run it.
Configuring an OS with almost has so.
Alright, you get it done.
I'm almost there. It's just finishing the record setup. I think. That's right around Rufus, so.
No, it's just, I'm just saying because like, if you don't have the exact indentation, will the other view?
That's right. Yes. So the tab key cycles for the legal indentations on the current line. And if it don't move, this is also.
Yeah, I mean, I did mine.
It's like the
I'm now-
linkage, right? It'll tell you from where it.
Oh, yeah. Arrows.
Yeah, it's.
Okay, yeah, you're on. No, right, you're like that, everybody else on the summer.
It's so early to see if we got it out.
It works fast enough for that, but not fast enough to download.
It's the same part of between your retailers.
Able to cross the ocean somewhere. It's last night. Surprise.
Twice the time, so. That less stress from that very side.
Yeah.
On your task. It's there. I think.
And are you running necklace? Yeah. Just regular old necklace?
I also use Nix, but I said no, I'll just install Record outside of that because it's not worth it. Like I have time to yeah, I think we know how this is gonna turn out. So this is the Zen browser. It's, I don't know if you're familiar with it, it's support by Firefox.
It just has some extensions on it. Cool.
Give me a few more minutes to play with this and then I'll go through some of it.
Yeah, you can do it like interpolate one of them.
She would, all right.
This was like the right way.
Yeah, in fact, I think you get this. It's still compiling, but mostly in the tests. We will just like use people around, break it back and go forward, whatever you do.
Yes.
Oh, I think your computer is just working very hard.
Yeah.
Yeah, but you should be able
Oh,
to.
yeah, there is.
It's close.
They have their own
This
way.
way. Mhm. Mhm. So that means it's partially installed.
Color correctly.
His breakup setup is in this compiling and about to build docs, I think.
Is there any way to install a package without the scribble docs?
Well.
Because right now it's rendering all of.
Oh,
just take control C. Okay. Stop it. Yeah, you don't need the docs.
Or just put it in the background and go open the thing up and back it, but you could just, yeah, I think you don't have to.
You don't have to.
I mean, if your computer's kind of getting tired, if you feel tired, you could kill it, yeah. Yeah.
Okay, we're just. It's okay.
Yes, the point is to guess, that's all right. Okay.
It's fine. Everybody has to do it, I'm like, yes, everybody has some stuff. Probably. Yeah, that's.
It's more, it's like.
It's very good.
It's not very accurate. So you pass it the least. One to three, you give it only one value. Over here, you define a function.
That looks like a little C plus plus parameter packs.
Yeah. Even it goes. All the way.
Yeah.
Okay. Wrong way. Oh.
Like using bracket language.
I am in Rocketline. I am in Rocketline.
So there's hash. That's a basic range. Try bracket.
Yeah, all right, I saw it.
Hash.
Fine.
Use that, but it's like.
It's very weird. It's interesting.
And I'll fix it to the fine bracket.
Oh, sorry.
If you have your couple.
It's like all your, it's like your elements.
Yeah, and then that's how you interpret it.
Oh, it's thinking.
You define how to interpret one of the elements.
Yeah.
And they do the same for us.
Okay, that's what it's like, they're just.
It looks like it's that's a little.
You never
It's alright. I think
start.
they're just use software.
Don't. You do like you, and then you're not.
All right, so hopefully you got to look at least a little bit of it. I'm gonna talk a little bit about the crash course exercises. So the first one, what you see is kind of Java style classes written in a lighter notation, that we got a base class expert and some subclasses. And so if you had enough time, maybe now or maybe later, then you no doubt would have written a minus class and an if class, where a minus has a couple of things and if has three things. And you have the the natural recursive calls here and metacircular interpreter where we use minus to implement minus and if to implement if, right? Make sense? Any questions here? All right, and maybe getting indentation right with your editor was the hardest part. For the second one. The key thing in the second one is we've changed to functions with multiple arguments. So we have list of symbol in the fun class. And that means that when we are calling a function, we also have a list of arguments here. And what you're supposed to get out of this, if you have enough time to look at it, is the dots here. So we're pattern matching on the call object with the function expression and any number of argument expressions. That's what means, match the previous thing any number of times. And then I can call the interpreter on each of those arguments. Again, so that the expression instantiates that repetition as many times as needed to make all those calls and calls the function. Our metacircular interpreter is representing functions using functions. So here's the function case, again, multiple arguments. It creates a rhombus level function that takes any number of arguments. And then it's going to pair up the formal argument name with the actual argument value to make an extension of the environment. What happens if someone calls a function with the wrong number of arguments, then these are not going to match up, and you end up with a rhombus error message, rhombus level error about the things not matching up. But if they call it right with the right number of arguments, then these will match up and it'll be able to complete that. So this is introducing ... and you would have to use it to do tuples. You know, tuple, you have a list of arguments, so you interpret each of those arguments and put it together in the list. We're going to use a lot of ellipses, a lot of these ... so that's the warm-up exercise in it. Any questions about this much? Okay, let's look at the third one. In the third one, we dispense with the classes. And just operate directly on representations of the program in a very Lispy way. Like instead, just like you might interpret directly on S expressions by pattern matching the S expressions, we're working directly on rhombus-like things, which we'll very shortly call shrubbery forms. So these quotes, these single quotes, do not make a string. They are code quotes. And inside it is not rhombus code, but it has the same sort of basic structure of rhombus, just like S expressions have the same basic structure of rhombus. So we're going to talk a lot more about shrubbery notation. The dollar signs are an escape. So here we're matching any syntax object where left matches whatever is at the beginning, but actually any number of lefts, as long as you eventually find the plus operator, and then any number of rights after that. And then when we make the recursive calls to interp here, we take all the pieces that were in left and put them back together in a new template, in a new syntax object that we make with this template. And so it recurs in the obvious way.
And basically implements operator priority by ordering with pattern matching.
Yes, exactly. So very, very cheap, ugly parser, good enough for a class that's not about parsing.
Correct.
Yes, indeed. Okay. And then here in the if, this may be worth looking at a little more. So rhombus style if is vertical bars for the then and else parts. We'll find that, you know, you may have noticed vertical bars for alternatives is a general theme in this style of syntax. But we're saying test ... That means that's because your test is often like, is x less than 0? So you've got an x and a less than and 0, you need to match multiple tokens. So that's what's happening there, and then the then and the else are similarly can be complicated expressions, which is more than one term. So that's why they have ellipses. So then otherwise, it's pretty much like. Yeah. So that's a crash course that's meant to just give you a sense for what rhombus looks like and what kinds of things we are trying to get to in a sense, but also this notion of ... and some tools that we have to work with. So I mentioned shrubbery already a little bit, and let's talk about that a little more. This is a notion that's inspired by Lisp's S expressions. So in a Lisp program, everything has parentheses and it does all the grouping and it's just parentheses. That's all there is. So it's very simple. We're going to see that shrubbery is more complicated than that. So not super complicated, but significantly more complicated. We have more variety in the syntax. But there's a similar idea that Sriram Krishnamurthy calls bicameral syntax, which is that the syntax of the language rhombus is defined in 2 layers, and every program has to pass both of the layers to be valid. So if you're in Lisp, it's got to be an S expression first, and then it has to be a well-formed lambda term or something like that, right? The syntax of your syntactic forms like lambda and con are defined in terms of the S expression, and so they don't have to worry about even token level things in spaces and commas. So shrubbery serves the same role in the rhombus roles. Everything that you do is going to fit first as a shrubbery, and then we can start talking about how functions are defined in terms of the shrubbery constructs. Great. So let's go into this a little bit more. Like here's S expressions. Oversimplified, but the essence of S expressions is just you have either atoms, which are things like strings and numbers and booleans and so on, or you have a parenthesized sequence of terms. And this is very simple, and also the way it's used in practice is that you use parentheses to group anything that needs to be grouped. So if you have a plus expression, it's got parentheses, and the times, it's got its own parentheses. And if you put times inside a plus, that's 2 sets of parentheses overall. So the first way that shrubbery is different from S expressions in sort of application is that we don't require the shrubbery layer to impose all of the tree structure, like the times and the plus and so on. Instead, we're going to rely on a separate second layer of parsing that we will talk about to take something like 1 plus x times 3 and group the times before the plus. Still, there's a lot of grouping implied by shrubbery. We do have parentheses and square brackets, curly braces, and the block structure level of grouping is mostly done with lines and indentation. So you had to fight with getting the indentation right, maybe, and doing the examples. So it's kind of Python inspired, and that we use colon to start an indented block, and because this is outdented, right, this call to F is outside of the definition. I'm going to use the words term and group a lot, and these are technical terms. So I'm going to use term to mean specifically like the F or the 0 or the plus, but also the parenthesized 0. That's one subtree, right? So term, you can think of as subtree, which might just be an atom or it might be this whole parenthesized thing. And groups are a sequence of terms that, roughly speaking, are all on the same line. So x plus 1 here is a group, and print line of parenthesized x, that's one group. This group x plus 1 has 3 things. This group print line of x has 2 things, 2 terms. The print line is the term and parenthesized x is the other term. Of course, the parenthesized x has inside of it more stuff, and those are again groups. So this parenthesized x has a single group with a single item in that group, or a single term, I should say, inside that. Meanwhile, this fun block, it has 2 groups inside of it. In the same way that the parenthesized thing makes 1 term in its enclosing group, this colon with the groups after it makes 1 thing. So the group that starts with fun has 4 terms in it. FUN is 1 term, F is 1 term, parenthesized X is 1 term, and the colon block, that's all 1 term as well, with more groups and more terms inside. So that's the basic structure of things. Just to point out, here's an example of a group that isn't just on 1 line, because print line and the parenthesized thing are the 2 terms of that group, but it ends up spanning multiple lines because of the parentheses. So that's okay. Same thing happened, of course, with the colon, where we span multiple lines of the group there.
So after a colon, you have 1 group or several groups?
After a colon, you can have any number of groups.
So here we have 2 groups, and
Here
then
we have
they
2
don't
groups.
form their own group.
Exactly, yeah. Right, here's the abstract syntax. So this is all the kinds of groups that you can have. So a whole document, well, it's a sequence of groups so that you can have multiple definitions, for example, in a module. We don't even think about that very much. We just start thinking about a group being any number of, I'm going to use an extra word here, item. So the items are the terms that are not blocks, or these alternative things. And that's just really because blocks and alternatives, they have to be at the end of the group. But most items or terms are these parenthesized things or square bracket, curly braces, or quotes. Quotes are like parentheses and square brackets. They open and close. And then a block makes a term, as we talked about with multiple groups. Alternatives is a slightly unusual one, and it's really not each individual vertical bar that makes a term to the enclosing group, but the whole sequence of vertical bars. Just this much structure. This is a lot bigger than S expressions were in terms of the grammar, but it's a lot smaller than the grammar for a whole language, like a Java or an Algol 60 or something reasonably small. Why do we have just this much then, or how did we decide this much? Well, distinguishing between parens and square brackets and curly braces, that's not too controversial. Even some list variants do that, like closure. Single quotes we add into the set here because we need to quote code all the time, so we pick something specific for that. Colon is here because we're using that for our block structure in a Python-inspired way. And then the alternatives, just from the early experiments, we discovered conditionals or branching forms or just any case where there's alternatives is very common. And it's nice to have a dedicated, a syntax that fits that very well. So that's why we build these particular elements into the language, into the shrubbery level of the language. Any questions? Okay. So, the abstract syntax is more complicated, not super complicated. There are various details about where the line breaks are and so on that I'm mostly not going to talk about. For our purposes, when you're doing the exercise, you will run into those. But like most people who use Rhombus, you just sort of get a feel for what it is without sort of going and learning how to write the parser for these things. So that's why this is about as much as I'm going to say in terms of the syntax, focusing on the abstract part. But we want to get some practice. It's helpful to get some practice with this abstract part. So that's going to be your next set of exercises. We're going to use not hashlang rhombus for a moment, but hashlang shrubbery. So hashlang shrubbery, like rhombus, has a shrubbery in the module of the module. But unlike rhombus, all it does is tell you how does this parse. Okay, so it's really kind of a debugging tool or exploratory tool at this level. If I run this, it's going to show me how many groups do we have here? 2 groups, right? The one that starts start, the one that starts end. It shows me how that parses using an S expression representation. So multi is just what we use to group together all the groups. It could have been called doc maybe. But then we have the 2 groups that have start, and there's a block inside there, the string hello, the string world, and that group, and so on. What if I add +5 here? What will that change? Hello and +5 are all part of the same group, right? So that should change this part, adding more stuff here. And then that's what we see. The only thing you might not have predicted is the op around plus. That's because shrubbery distinguishes operators from identifiers, and S expressions are kind of the same thing. So in the S expression representation, we just make it explicit. This is an operator. And in rhombus, it's a syntactic distinction, right? Plus is an operator, X is an identifier.
When you replace 5 by X, or add minus X or something?
Okay, let's put minus X here. So the minus ends up being an operator that probably would be implemented as a unary operator, but at the shrubbery level, it's just a minus operator.
Like X is just a symbol.
And X is just an identifier which you represent with a symbol. Yes. Okay. You ready to try this game yourself? For your exercise, what you should do is go to the notes again, into the shrubbery notation section, which mostly tells you what I just said. It tells you a lot more details if you care, but I recommend you skip that. Just going down to this exercise where you're going to work backwards. I showed you how this code produces this encoding. Here are some more encodings. Write the shrubbery terms that would produce those encodings. So give that a try for the next 5 minutes or so. And probably everyone's clear on this, but Robbie Findler is also answering questions. There's 2 of us. I would expect that if they had tabs, it would indent,
Yeah, I don't know why.
but it's not, and I'm hesitant to just do that.
I could run.
We'll see what that.
So the problem here is you are in the correct language. You are not in the right language. So you just click this little link button right here. Okay, running it. I think that will work. Like you expect. And then. Some other time experimentation. Yes. Other times we don't have language in an old way.
Yeah.
Nowadays language is you just change the first line and.
Okay,
That's. Gotcha. Okay, so you're getting this stuff, right? Then the other, I'm gonna say, tell you another thing, so just and shit well. Okay, so when you run, so actually slide by that, yeah. Like bracket will. It'll pre-print this based on the width of.
oh, okay,
So I don't know why it didn't do that. No, I was thinking it's not wrong, I'm not sure it's. Okay, well, yeah, sorry, that's it's easier for reading yes expressions.
okay.
But I'm sure why it's not working for you.
Oh, it just worked actually, changing the file. There we go. It did it now.
It's like doing it now? I don't know.
I changed the file and then it did it.
Weird.
Yeah.
That record wasn't picking up the width of the window to do the rate.
So,
But there it is.
so when this parse is Q is a symbol, as opposed to like an operator.
It is a term.
It is a term. It is term. Is it possible to extend the set of operators? Like, can I add my own operator? I mean, not just.
So, okay.
Well,
The bicameral thing,
Yeah.
forgetting about the bicameral thing.
uh,
Well, all we're doing now is like talking about the thing that replaced S expressions.
yeah,
So.
but like
that's-
thinking forward to run this, if I want to program it, can I extend?
I mean,
Yes.
yeah, when you get to run this, yes.
Okay, we will do, that. Okay.
That's-
I was just.
At the shrubbery level.
No, it doesn't matter,
Bunch of
yeah,
words.
it's just a bunch of words, yeah.
Oh.
Working with this, that's not that.
Coming. And it's making sense. Yeah. I think it's coming. It's like good. Okay, let's get it. You're doing all the good.
So that's what thing is. Oh, yeah.
Yeah. Yeah, but I don't know.
Yeah.
Oh, pretty cool.
And I think you directly, it's not king of the concert.
I never went over, I would much prefer to write on the script, but I never went problems for getting comments.
Oh, okay. This pipes here, this is an S expression hinting issue. This means it's the operator whose name is Dot. Yeah, it's just that in that expression, it's Dot means something else.
Yeah.
Interesting. So that's why.
Yes.
Yeah.
It was not.
So like. All the coding issues.
Because the thing that happens after a vertical line is the angle is visible.
Yeah, the
But
only
that's
thing
zero.
I'm struggling with is.
Just put that.
But yes, it's not.
Right.
This
Like this.
Yeah.
Okay, so, alright, so the point is based on using my. And just that means.
Yeah.
So the pipes are like this. Pipes are around.
So bracket has. So the problem is process program. You see, yes.
That's why.
You're just part.
Yeah, I think.
Okay, you tired of this game yet? Let me do this first one quickly, just to get us all in sync. So the middle one, actually, I'll do the middle one. So we see
Yeah, he's gonna talk about it.
a group, a single group, and then quotes. And then maybe since you know quotes are special, you guessed that you need to use quotes to get that. So that would be a good start. That gives me just the multi-group quotes. And then you see I have two groups inside there. So I'm gonna make room for myself to have 2 lines there. Because you know groups basically fit on the line. And then I've got the word math, that's easy. And then op vertical bars, I didn't really think about the vertical bars when I was making this, but that's how S expressions print because dot is special on S expression. But not here, it's just an operator. So you just write math dot, and then max, and then parens. Okay, we're getting the hang of this, that's probably just the parentheses like that. And then we have 2 groups, and it turns out we could make room to put it on 2 lines, but inside of parentheses, groups are actually separated by comma. So parentheses, square brackets, curly braces, they use comma to separate groups. And you can make it a comma with a new line if you want, but the comma is the important thing. So we need, then we got an operator, $, an X. You can put spaces or not. And then we got this operator, dot, 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 just like that. So I'm getting close. I got the math and the dot and the max and parens with the right groups, and then I just need one more group with just dot, dot, dot in it. So I could do it like that. And I think I got out the right answer there. Is that right? Yeah. Okay, and you could, put this on different lines if you want to, like that. That would be fine. You'll notice that the indentation that I cycled through suggested this as an option. If you try that, you might be surprised by the result. So if I put an X in the front here, then I get wrong indentation. You've seen that once or twice probably. If I take the X away, it's actually happy with it, but it meant something different if you look closely. It turns out the dot, dot, dot is still in the same group. So this is, I've just stumbled into an extra rule here that says, if you start an indented line with an operator, it can continue the previous one. But we won't need to do that today, so I will just not do that again if I can help it. All right, on the same page, any questions at this point? So if you don't ask questions, you know how this goes. I just plunge ahead and it's gonna be done. Okay. Well, now that we can deal with shrubbery, we've got shrubbery, we know that they get parsed somehow. But actually, I'm gonna start using the word parsed, not in that sense. I'm gonna use parsing in a technical way, and I'm gonna call what we just looked at as reading. So this terminology comes from Lisp, where we read to decode the character sequence into a shrubbery. And then once you've read something, so if you have a rhombus program, you have to get past that barrier first. Not even a shrubbery form, then nothing else will happen and you have to fix that. But then once you get past that, then the goal is to take some shrubbery representation, which I'm drawing as a nest expression representation here, and converting that into the AST. So something like the lambda code, let's say. There is some core language that we are going to expand down into, but I'll call that a whole parsing because it'll be expansion mixed with some infix stuff. Right, so we agree to use the word that way from now on. This AST, I'm putting the lambda calculus here as a kind of placeholder. when you see rhombus, the whole language that you get from hashling rhombus, then it has some stuff that maps down to simpler things and something that's probably truly primitive. Let's not worry about that today. Let's just say everything that hashling rhombus gives you, that's all stuff that has an AST, even though that's not really true, it really has some more boiled down thing. But it's good enough for our purposes to say there is some core language, like the export of hashling rhombus, that everything else parses into. Right? And then there's an AST behind that. Make sense? All right, so here is something that's not in core rhombus, but the kind of thing we might want to write. If you got looked at interpreter 1, and if you've ever used ML before, you probably would have rather written it this way than all of those class declarations. So let's set it up so that we can write it this way and get those class declarations out. And the first step of parsing this into that lower AST is to think about what is it at the shrubbery level and what pattern can we match on. Okay, so we're going to think of, mostly we're going to think of these rewritings as pattern matching on some shrubbery to rewriting it to another shrubbery. You can work at an even lower level and iterate over things, but we're going to use patterns everywhere. So here, clearly what we need to match on is the word data type at first, but after data type, there's always some name. So I'm writing in quotes, in a pattern matching position. This is going to, in a pattern position, this means a syntax pattern that matches literally data type, and the $ escapes to say name can match anything like expert. I called it name, I haven't actually constrained it to be an identifier yet. We'll come back to that. Right? It just matches any term at the moment. And then I got a vertical bar, and this says a variant, and then another vertical bar and dot, dot, dot. The dot, dot, dots here, just like after a comma, it means repeats the group before the comma any number of times. When it's by itself in a vertical bar, it means repeat the previous vertical bar thing any number of times. So that's how we're matching any number of cases of our data. There's a lot more ellipses though, a lot more dot, dot, dots. We got variant, we'll stand for the variant name of each of these, and then field. If you look inside, the groups inside for fields have multiple terms in them, right? We've got a name like fun, double colon, and some other name like capital X. So that's why I write dot, dot, dots here to match any number of terms for my field. And then comma, this dot, dot means any number of fields. Okay, so we've got all of these pieces, but what does field mean now? It's standing for all of those pieces, right? It's 3 deep. This dot, dot, dot means any number of things within the group and any number of groups. So whenever we use field, it'll have to have 3 dot, dot, dots after it to say how to reinstantiate that match. If I try to just use field by itself, it won't work. Let's try this. Let's go back to Dr. Rackett. So I've got a simplified version of the example from the slide. Now in quotes, right? This is the data type we want to accept as input. And so I'm writing a define input to be that thing, right? So clearly, if I use input, it's the same as writing that. And then I'm matching input against this pattern that we had on the slide and just saying, yes, it matches. I'm referring to name here and putting it in the result here, and that works like that. So far, so good? I'm gonna not use match. I'm actually gonna just use def. I'm gonna say define the things in this pattern to be a match to input. This I think is a little less obvious. What's going on here is whenever you write a definition, like if we define X to be 7, this is actually a pattern matching definition. I'm matching X, the pattern, to the value 7. But I could put X comma Y here, and that would match a list 7 and 8. Right? So now X would be bound to 7 and Y would be bound to 8. And this is just another pattern right here. So this is a pattern. And so I'm actually defining name and variable and field. And that means I can use name right here. And it tells me expert, right? That's what we matched up. We're matching to the input. What if I type variant? Okay. Which word is variant? It's actually 3 different words, right? ID, fun, and call. So if I write just variant, it'll say you can't do that. Variant is a repetition, not just a plain old variable. But I can say variant, comma, dot, 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 and build a list with all the things that variant stands for. Make sense? Right, so dot 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 in a pattern matches multiple things, dot 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 in an expression instantiates the repetition. And of course, there was no connection between the square brackets and the fact that it came from pattern syntax before, right? It's variant stands for each individual bit. Let's try the same thing with fields. So field dot dot dot. That is the innermost dot dot dot, right? So that's name colon symbol maybe. And then we have any number of those, right, in the fields within one case, and then we have any number of cases. So if I do enough dot dot dots, then I get all the things that fields stand for.
People get one, we tell you it's a
But if I forget one, it'll tell me.
It's a repetition,
Exactly. Oh, I hit it with my exclamations. Yeah, let's try that. Let's try getting it wrong. I will remember that I can't use escape. Let's try just two of them. Then it says wrong repetition.
Wrong repetition tenants. Yeah. That was quite a thing. Like that, it has that.
Yeah. So this repetition depth is a concept there. Okay, makes sense. Of course, we didn't want to just put these things together in a list, right? We were trying to generate the set of definitions to replace things. So like I had on the slide, but I didn't talk about yet, we can write quotes. This is in an expression position now, so we're generating new syntax. And dot dot dots work inside the quotes just like they worked in the list constructions. So just dot 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 is saying repeat any number of classes where each one has a different variant. And then there's associated fields. So if you look at this field, it's got these dots and these dots. And since this is repeating that dot also applies to field. So we've got the 3 dots again for field. And similarly variants. Name gets duplicated as many times as necessary. And as long as you have something driving how many times you do the repetition. So if I run this, then you see we get, as a quoted bit of code, it's the code that we're trying to generate. So far so good. There's an awful lot of ellipses here, right? A lot of dots. And I think these are the most tedious ones. Where like you wanted to think of it as a field, but a field actually has multiple terms in that comma. It turns out there are some conventions that make it easier. So if you have a $ name that's by itself in a group, it's allowed to match the whole group. If there are more stuff in the same group, it can only match it. Yeah.
You had a question?
Yeah, we have like, how do you represent a variant without fields in this?
A variant without fields.
And let's say we don't want to have like empty field, like just
Okay.
variants.
Yeah.
So the pattern language is expressive and I could do things here. Yeah, I'm not gonna get too far into this, but you can do something like match this or
Alright, okay.
just vary this. But there are some technicalities here because or doesn't let me bind things, so I really need to use some more machinery.
Okay, alright.
But that's what you can do. Syntax, you want a separate syntax class.
I think it's okay if you have like empty brands, like.
Yeah, just have empty.
That's part of my language, what are you saying?
All right, so you can see it still works. I took off dot dots here. I also had to take them off here, right, to be consistent. So what's happening is that this convention just makes it a lot easier to get your macros right in a lot of cases. Can be a pitfall. Sometimes you can be surprised that you're matching a whole group or what if I really did mean a single term here? It turns out you can annotate these and I sort of showed you a little bit of that. To say, no, really just match a single term. So term is a syntax class. And now my pattern match will fail because this isn't just a single term. You could say group, and now it works again. And so the conventions are really about what is the default syntax class there.
And this thing, term and group, you can define your own one to get what you guys write.
Yeah, exactly.
Gotcha.
Yeah, so you could define field and then write it this kind of way. Another thing you might do here is, I'm going to switch this back for simplicity. Like, what if I say data type 7 here? I mean, it'll still work. I'll say make a class 7 extend, but I don't want that in the end, right? I want someone to get an error message if they misuse it. So this is another use of these syntax class things. I can say a name which has to be an identifier. Name for undefined.
This is the example, right?
So that's the input. I'm sorry, thank you. I was modifying the wrong thing. Right. Okay, it's because I was escaping. I'm not super happy that it said name for instead of name and highlighting name, so Robbie and I will fix that one. But this is what I wanted to get, it doesn't try to match anymore, it says it doesn't match. And if I were using match, it would actually give me a better error in this case. But anyway, we'll come back to that. I think everyone's in sync here with what we were trying to talk about. So this is patterns and templates. I don't have to write quite as many dots. There's a convention that makes it a little easier. I have written out an example match and then used it directly, but of course what you want is a function in general that's going to map from the input to the output. So we rearrange this just a little bit more and we get this myExpand function. So myExpand takes an input, it does the kind of match we were doing. Here I put that template construction in the body of the match instead of making separate definitions. And then I can call myExpand on the syntax, even simpler version of the example, I think, and get the code. So this starts to look like a macro, right? It starts to look like I've written the expansion, the parsing of a data type into the code I want, but it's all at runtime right now, right? This code in quotes. If I try to use data type at the end here, I put this declaration down here as part of my code, then it's not going to know what data type is, right? There are two things going on. One is that there's no binding of data type that would cause this to happen, but what should that binding do? It should run a function at compile time, not at runtime, or at parsing time. So just a little terminology, runtime versus parsing time. Runtime is when you actually run the program, and parsing time is this parsing step of elaborating down to the primitives to make the AST. Sometimes I will say expand time, and sometimes I will say compile time. These are all the same time that relative to runtime, right? So I will use those terms interchangeably. How then do we inject a function into compile time? We know how to get functions into runtime. That's what we do all day. To get it into compile time, well, first of all, I need to use not just rhombus, but rhombus and meta. So this says, not only do I want to write runtime code, I'm also going to write some compile time code. This is equivalent to using rhombus and importing rhombus meta. So and meta just combines those two sets of bindings. When I use rhombus and meta, then I can write println, but I can also write meta here, which pushes the code to parsing time or compile time. So we use meta to mean happened earlier in a sense. And the question came up last time, you can have meta time. If you're writing compile time code that you want macros for, that can happen, but this will be enough for us.
You're doing the import. What does the word open?
In rhombus, as opposed to racket, when you import from a module, it ends up with a dotted name. Like if I imported just meta, then I would have to say meta dot something to get out from that. And so open just opens it up. And rhombus meta does that. Okay, so well, you can see what happens when I ran it, because I ran it last time. I forgot to close this. But you see parsing happening before running, even though they're in the other order, and textually, but that's because meta time has to be completely done by the time you start runtime. So parsing printed here. If you try this in yours, you might see parsing print twice because of the way Dr. Racket does debugging. It wants to parse things multiple times to get the debugging in place. But that's fine. We assume it's okay to compile programs multiple times, but when you run it, we just run it once. So we could then put our my compile or my expand function here in meta. That would be half of the answer, right? We would have moved that function to compile time. We still need though to set up a binding my data type to that compile type function. So instead of writing my compile inside meta, I'm going to use defen macro, which is combining those two things. And it's also combining a match for your convenience as well. So defen macro expects to have a pattern right after it. And whatever this pattern starts with, that's the name it's going to bind. So you can see the arrow that Dr. Rackett drew there, showing that this is referring to that definition. And then we have the same sort of patterns that we had before, with constrained the variance to be identifiers as well in this case. And we have a use of it with data type, and that works now. I can run this, and here's the interpreter using that, just like if we had written out the classes before. So again, defen macro does those three things: creates a connection between the name, it moves things into compile time, and it sort of sets up the matching for us. And if I write 7 here, and we've already seen that that's going to go wrong, and it's a data type expected identifier because these pieces are all conducted that way. All right, I think that's enough of me talking. Yeah, that's enough of me talking for a minute. Let's do another exercise. So go to post shrubbery parsing, and then scroll down to the end again, where there's a little exercise to do with the interpreter. So interp def and macro will look somewhat. Yeah.
So it's actually, it's good to say. Actually, you're gonna go further. Looks like it's not. Yeah. It's like it should be. That's what she is. That's what we can. That's where the concept.
Yeah.
Typical sequence without regular code. Saying. All the great others.
That's nice. Playing around, it's fun to like just like, yeah. Good question. You guys. You guys switch also there. That's true, yeah. Yeah, got a point. Oh, you did without it. But yeah, this is the work got it called out. Yeah, you just get it. Yeah, but yeah, you find one thing.
I changed the pattern.
Yes. Yeah. And it was straight away.
Actually, we could have a nice keep name fields a little hard to change that. Largest passage and just passing that to the field. Was anything? What do you mean? Like right now, I changed all of that.
Yes.
So now I have two names that one in the house. Really, it's just formed things, so.
Oh, I see, you wanna like take this whole thing and say like,
This is
as X, and then put X down here.
Right. You can use and.
Oh, and.
And so we don't know pattern stuff.
Right.
Always say that when you go in, I think it's good.
I'm changing already, right?
Oh,
yeah.
So what is this show that?
I'll show you.
Okay, that's fine, anyway. It's just as a picture of it. Expecting value to A7, that sounds good.
How are people doing? This is supposed to be a shorter exercise. Okay. Sometimes the expectation doesn't match reality.
There's lots of interesting corners you might find yourself in.
That's right.
Depending on what you try.
Yeah, let's do this. So the way I would do it is I had field before. So now I'm gonna have field name, colon, annotation name. And then of course that means I need to change my generation. That's a good start, but I still haven't constrained the field name.
It's an only, that's why on one time.
Exactly. So field, oh well, the field name.
Yeah, like.
Yeah, exactly. So I didn't get anywhere, right? Because it still matches. I have to do the intended constraint, which is that this needs to be an identifier. Now we get an error message from a data type. And if, just because this was a question, suppose you want this whole thing to still be called field, you can do that. So you use field and I'm using that thing, and then go back into quotes and do it this way. Then you can still write field down here. All right, so bonus because someone asked the question. And it's easier to use than or, it turned out. And you may recognize that pattern from ML style pattern. The general thing in the patterns.
And the new line and what you said you wouldn't do again.
Yeah, which I said I would not do, but I wanted to make it good after.
But didn't you just require to always have a notation?
I did require it, and it wasn't required before, that's right.
Yeah, it wasn't.
So what you might want to do instead, really what you wanted to write is field, which is a field here. And have your general syntax class that helps you with this. Okay, but we're all on the same page now. I think we got the idea. Now we've done macros. We could declare success, but actually we made things easier by doing definition macros that always start with a particular word, right? And of course, part of the problem that I set up is dealing with infix things like plus and times. So we want to unpeel the layer just a little bit to help you understand how that works as well. Again, it's one of these things you wouldn't necessarily need to understand in depth to use rhombus, but the point of the tutorial is to get into these details. So with that in mind, I'm going to say parsing in general is actually two different things on the inside. It's inforestation and expansion. So inforestation is the part that figures out that plus is an infix operator and it has a certain precedence relative to times. Okay. And expansion proper is taking some pieces that have been enforested enough that have been turned into a tree structure enough and generating the resulting is. So just for example, in this rhombus expression, this is the list 1, 2, 3, and then I'm removing the element 2, and then I'm using a F-sharp-like pipeline operator to send it to the parent function. But how does this get parsed overall? It's that this list construction gets enforested, but then it sees a dot for the index. One key thing to note, this dot, the right-hand side, is not actually an expression. So dot needs to get control to say how to keep going, and it's looking for a method name, and then discovers a method call, in fact. So we need to figure out that dot is infix, but not necessarily enforced on the right-hand side evenly. But after dot does its thing, it leaves the pipeline and the print line intact, and so inforestation picks back up and keeps going. So that just illustrates to some degree how inforestation and expansion interleave. I'll show you a little bit more of that. But now think the question that people have in mind is, how do I make my own infix operators? Yeah. And at first we are, we're not talking about macros anymore again, we're just gonna talk about operators. So that's a function definition, not new, right? Function in red list that takes A and B and creates a list with them in reverse order. So when I run this using banana apple. Here is an operator version of the same thing, and it's using the operator function that comes from just rhombus. Notice it's not rhombus and meta. It probably works pretty much the way you read it, right? So it makes the less than tilde greater than operator do the same sort of thing. I will just note that I've made this at the top level, but it could be nested. So this is another reason that inforestation and parsing are interleaved, is because I could have local operator definitions, just like I can have local function definitions. Maybe this one looks, maybe let's have this one create a set instead.
So local definition is really just a function definition.
Plus a macro.
Plus a little bit. Parsing.
Yeah, hold that thought for the exercise. So that'd be a great exercise. Implementing operator using a function in a macro, yes.
Yeah, thanks.
But before we get there, my point here is just that a certain amount of parsing AST construction has to happen to discover that this is an infix operator. So that's another reason that the things are interlinked, but we don't need to go that.
So you could have different hierarchies in different subjects.
Yes, that's right. Yeah. So yeah. So what if I want apple pie and banana cream cake swapped? I can do this, but you see those parentheses, right? We're trying to not be Lisp in some sense and not have parentheses. So what happens if I take them away? Then we get an error message saying, I don't know how to resolve the precedence of these things. So I could say that this is weaker than, the operator form lets me say it's weaker than plus plus. And now it does what I want. It would get tedious to name all of the operators that you're weaker than, potentially. We can do better with grouping. What's it called? Concatenation. Concatenation. If I look at the documentation for plus plus, it says it declares its precedence to be in the category, concatenation category, so I can just make it weaker than everything. But precedence in rhombus is not an order. It's just pairwise declared. So you don't have to, because you want certain arithmetic operations to be weaker than others, that doesn't mean it has to be transitively weaker than others so that you get weird Boolean versus integer things that you get in some settings. So we take that from Fortress, and it's worked out well for us at least. So that's how you define an operator and declare its precedence, and you can see how it's the binding of the operator and the interplay with inforestation with these declarations. Let's see. Yeah, that's covered everything I meant to here. So, yeah, that was an operator, which is analogous to a function. But what if you want something like dot, where you need more control? Like operators implicitly, there's an expression on either side of them that get parsed out and sent in. And you can control the precedence, but not the fact that those are expressions, or not the order that they're evaluated in. So if you want to take that sort of control, then you need to define a macro, an infix expression macro, as opposed to a definition. And we can do that like here. So I'm back to rhombus and meta land. I'm using expert.macro instead of defin.macro. I'm writing a pattern similar to the way I wrote it with defin.macro. But now I've got the thing that I'm binding in the middle here. Okay, so defin macro doesn't let you put it in the middle, defin insists that its prefix expert does the full inforestation. You can define prefix macros the same way, it's just whether you have a $sign identifier before it or after it. Before it or not, this is whether you are defining an infix operator. And I make it weaker than, and here I've used block just to make it really explicit that I'm evaluating the right-hand side first, and then the left-hand side. Probably not a good idea, but for example purposes. You can't tell an apple banana there, but if I add this trace function, and now I have a side effect happening for these two expressions. then we see that banana prints before apple in addition to being first noticed. Okay, whereas that was not what would happen with our operator declaration. Adding trace, there's a subtlety here, like $A, we've talked about patterns, it says matches only a term, but I don't have a term there anymore, right? And also there was no error about precedence, right? And so the precedence part is because the function call form says I am stronger than everybody. So it's pairwise, but you can say I am stronger than everyone, or I am weaker than everyone. And between a small set of categories that you care about, plus these two things, that really covers most of what you want in terms of precedence. So that's why the precedence works out. Why am I able to have multiple terms? Well, because X per macro is cooperating with enforestation. And so the $A implicitly means match a parsed thing that has been represented as a single term. And if that's not what you wanted, well, too bad for an infix operator, because you have to parse the left before you get to the right in our world. But if you wanted something different on the other side, on the B side, by default, that means the same thing. We could annotate this and say, just a term before you parse it, or some other things. So there's an extra layer of convention about what X per macro does with its patterns on top of the conventions that are for patterns in general. If you're interested, you can look at the tutorial notes for a little summary of those extra conventions. Right, but that gives you the idea. So yeah, time for another exercise. Go to the enforestation section. And there is an exercise, two exercises, okay. 4.3 and 4.4. So I'm gonna let you work on this longer. And then we'll do a little summary of the rest. Yes, but you may need to look at more of the notes. Okay. Yeah. So where is something that you got stuck on, or did you get stuck on?
I was trying to change the order. I just guessed that this was addition, that's a subtraction would be.
Okay. Okay, it's Jack. So yeah, subtraction is the same category as addition. So it's called addition, but it really covers addition. So. But if you wanted to put an order between those, you could introduce a new category or just name it.
I'm just going through the rest of them, just I guess I'm looking for the docs as cheating, so it's just.
That's right. Yes. Yeah, I guess you're supposed to ask. Oh. Yeah, that's right.
So the next thing is I can just use French quotes instead of single quotes. That means generated quotes of terms. That's the question.
Yeah. So the French quotes are just the single quotes, so that.
Yeah.
Yeah. So in the rare cases that you need to distinguish it.
You can make this.
You can imagine making people hard. How do I like that?
Or it's smaller than small than always part on the next things. Yeah, if you have a composed piece, you probably should see. Oh boy, we have a test set up. What is this? Slash. What's happening next week? That's like, what was that thing? You're not gonna do something to actually make one. See, yes. Yeah. Yes. Here we go. Right. My 3,000 media. Yeah. So yeah. Oh, if I just time, that's just yeah.
So I want this. Everything else, see what's.
Also, takes multiple arguments. It's like yeah. Oh, it's just yeah. So the reason that you can find. Yeah, I think the other way will also work. Yeah, and there's a way to train over his. Say we could have a boss. I guess I just don't. It doesn't give another approach. Just yeah. Always skin. I mean, why do you want to? It's good, and it sounds negative, but it is a very positive statement. I was looking at the page. Oh, yeah.
I'm assuming I cannot interpolate English string with like I can't do this, can I?
No. But it does take multiple items.
That's
So
what I print like.
you can do it that way. Yeah. Oh, it's. Oh, yes. Oh.
Why doesn't it noise?
It's just.
It's so. This one is. Well, it's just.
So actually it tells you there, it's stop.
When I was.
Use those dollar sign.
Oh, it's dollar sign. So this,
Yeah.
okay. The arrow is somewhere else. So this,
And then it's
and it's here to here.
And then it's just regular.
You want. Leave here.
Yeah.
Otherwise, okay, so it's not a substitute.
Maybe you could, well, it's a substitute piece, just so. Very competitive.
Close. I think it's close for entry.
So I don't know.
Exactly.
It's already achieved the.
Yeah, so this is a macro generating. It's already got the, use the states variable.
Yeah.
So you can just have your macro.
Okay. From and down this thing, but it's one panel, something like code. You know, this is very good. That's not right. So.
Yes, I didn't show you.
So he's saying that here's that fine.
Oh, no, you need to use the money.
Can I just do that? You try to be similar then.
Oh, that's sorry, I'm just like, no, just use name. That's all I was trying to say.
Full sense, right? If you
But we're.
Wait, that was- Yeah, and then.
No. Is it like the name every time?
Right, different names.
Oh, it's Jensen.
It's not Jensen, but it's hydraulic.
Sorry. Yeah, no.
That's not the problem.
Yeah, that was. Surely that was.
Oh, you do what I do, fine, instead of that. I gotta get that right. You overloaded it.
Yeah. Definitely, there was something maybe.
I did write it down. Yeah.
Well, that's not kind of.
That is a pattern.
That's why these things collide. That's you can have a pattern constructor.
I think it moves to the other side. Yeah. The channel. Yeah, it's just one.
I mean, that's the last.
Okay, so you.
Yeah, I mean, you could say, yeah, people.
Which is weird, like, because I
Collaborative.
expect this.
Sorry, you know, just like on the scroll.
Even both.
Okay, let me say just a little more to wrap up here.
But it's not.
Just if you were doing the second exercise, I'll show you a peek at what it looked like.
Maybe because it's
Uh,
impossible.
At least I thought it would.
Yeah, I guess. It's not.
So it looks like this. Then you have a function and then a macro that calls that function. I have to say these escapes are a little tricky to get right. Fortunately, I don't often write macro generating macros. More often than most people maybe, but still often enough it doesn't show up that much. So this turns out to be a literal dollar sign in the expansion. And then you can just make up any name go because macro hygiene will take care of making it distinct. Right, any questions about the exercises in general?
Yeah, I kind of did it with expression macro.
With the expression macro,
Yeah. The expression macro, yeah, but
like this, yeah,
no,
no,
like as an operator example that we had. When you have an expression macro, but your operator is log s. Essentially.
oh, you did it a local.
Yeah.
Okay, I'm not sure I understand, but I
Alright.
will be interested to take a look at the end. Yeah, I want to see what you did. Well, if you find this interesting enough, there's more in the tutorial, and so I just wanted to tell you what else is there. We did the first line here through deforestation. Spaces is about what we've seen, there's definitions and expressions, but there's a lot more. There's bindings, there's escape patterns inside of quotes, and all of these are macro extensible positions. Right, so the reason that quotes work in a binding position is actually because there's a quotes extension in the binding space that decides what syntax patterns mean in a binding. And well, but when you write quotes, there's no keyword there, right? Or if you write 7, it's just the number 7. How does 7 get its meaning? And maybe you need a language specific meaning for even 7. So there are some implicit names that you can define. That is what the enforesting engine tries as the operator. So for 7, it tries #% literal 7. And the names have #% in front of them to say, sorry, you have to see this. Usually it's invisible. So you can read more about that. Once you have those pieces, you have enough information to build your own little language. Like if you want a language bigger than rhombus, you can make macros. But if you want a language smaller than rhombus, you need a way of describing the starting point to have a hash lane that's smaller than rhombus. And so the last little bit is making a language in that sense. And of course, if you do this and go through more of the exercises and you have any questions, we'd be happy to take them here or by email, whatever you'd like. Okay. Thanks for attending, and I hope you enjoyed it. Let me know if you have anything else.
Thank you. You were something else.
I was talking about 4.3, I guess.
You was
Oh,
talking-
okay, really?
Yeah, this one.
Okay, great.
Yeah.
And then yes.
Yeah, but I was kind of surprised by
So this
this
is
was not evaluated.
well, because it's in quotes, right?
Yeah, I guess.
So you're doing the conversion to a string. Right? Because you're expanding to branch of some quoted to such. What if you wanted to do the second? And convert to a string.
Yeah.
Then you would want to just do two string. This.
Yeah, I
Oh, this is the other.
yeah, that's the right one. Yeah, I mean, both of them, are right? But this one compile time. Yeah. All right, makes sense.
Okay.
Thank you. Is there a way to on the chat level compile time?
Okay. I will just cut it. That's actually
Like,
so
with that,
line
let's
is
say,
revision.
like I did this, so I got this thing, I installed it, all the
Okay.
one.
Was that intention?
While I could do it.
Basically, you would test.
That actually tests like the minus and
For my wife's school.
Oh,
Sign it, check, verify.
right, we only gave you some test cases in the very first one. The crash course, and not in
Oh, well, I think it's.
other things we generate.
If you feel like it, I think you
That's true.
I should disconnect from Zoom and everything.